Well, hello and happy Valentine's Day to everybody out there. It's Friday, the 14th of February, 2025. My name is CareyHolzman, and thank you all for joining me. Welcome back, all the members and regular viewers here in the live chat. Welcome in. Good to see you guys. I see Ben Laird contributed £10 already in Super Chat. Ben joins us from Scotland, as does our friend Buster, who contributed even before the show started, £10 via Super Chat. Thank you, Buster. Buster says hello to everyone and all the best from Bonnie, Scotland. He says the temperature in Edinburgh, 35 degrees Fahrenheit, 1.6 degrees Celsius, expecting rain and snow soon. Rain and snow. I thought those were only in Disney movies. We actually did get some rain yesterday here in Phoenix, and we might get some more today, but not much. Barely get wet, basically. It sounds like it's warming up there in Scotland. 35. Stay warm, Buster. Thank you for your contribution, and of course for being such a great friend to myself, Mara, in the channel and community. And welcome in. I see John Paul Bacon and Badger, Andy Kane, John. I see, of course, Mara there and Luke Greenia. So hello to Scott and Mortant. Doman 2000 says hello. David Herzog and John Williams joining us. Anna Lindas says hello. Jim Stone says hello. Welcome in, Jim. There's Rick Lakes joining us. Human Sonic. And Eddie Casanova saying hello. Kurt Schlegel. And Dazzle555. Chris Dunn. And Robert McCord Magumi joining us in the chat, along with Barry Klein. William Denton contributes $20 in Super Chat. Well, right on. Thank you, William. Martin Postema joining us says hello. Darren Gilholm and Bajan Guy saying hello. I love this community. Fred Vandermeulen, a name I can't pronounce. Is that a Slavic name? Movic. I'm not sure how to say your name, but welcome in, and my apologies for my lack of global understanding of names that are common in other countries. I'm American. That's my excuse. I'm a moron. But welcome in. And if you spell out your name phonetically, I'll do better. I have no idea how to say that. Charlie Purdy, welcome back. He's contributed a new membership, now a member for 8 months. He says it's been a pleasure. Time goes by fast, right? It's been a pleasure for us, Charlie, and thank you again for your contribution the other day. We appreciate you very much, and of course, with or without the contribution, we appreciate you very much. Phil Stodd joins us. Easy Otter says hello. And Al Perez says hello. There's Mark Gaines saying hello. Right on. All right. Well, I hope everybody's having a good Friday so far. And today I would like to try to focus a little bit away from the chat room today. We've done a lot of that lately, so that I can get this water block hooked up, get the umbilicals hooked up, and be able to set this aside for the next project that's in the wings. So far, we've had the luxury of being able to sort of pace ourselves with regards to trying to find a balance between I certainly appreciate when folks in the chat have questions, and a lot of times when I do a Q&A session, people are relatively quiet. And then when I do a build, for whatever reason, it draws people to the channel, I suppose, more than a Q&A. And of course, they ask questions. And I always want to prioritize your questions over what I'm doing. But at some point, I do need to get back to what I'm doing and then sort of postpone the questions, because I can look here or I can look over here. But I do try to stop from time to time and take a little break so we can address anything. So I don't want to discourage you from asking any questions. And furthermore, there are other members in our community who may fully have the answers you're looking for, in many cases better than I do. So always look to the community too for any questions you have. They're all wonderful people, and it's a very welcoming community. So if you're new here, we want you to feel comfortable and welcome. And yeah, I mean, it's one of the most amazing communities I've ever seen on the internet of this size, that is just universally kind and supportive people. And if that feels like something you want to be a part of, the invitation is open to come join us. Just be kind and supportive to other people. In fact, if you're watching this right now and you're not in the chat room, and maybe chatting isn't your thing, you don't know what you're missing out on. And what I would challenge you is to just say hello in the chat room, because if you don't, we don't know you're watching. So if you just say hello, just watch what happens. And if that doesn't encourage you to respond, it won't be because you didn't feel welcome. All right. So we'd love to hear from you, and we'd like to know you're watching. And let us know what country you're watching us from. So, all right. So today we're picking up where we left off, where basically the whole build, there's usually 2 parts, sometimes 3 parts to a build. One part is prepping the motherboard. That's getting the board out of the box, getting the CPU, the SSD, the RAM installed, and doing that all live, along with installing Windows 11, doing all the updates and configuration, testing the speed of the NVMe to see that it's in the range of where it should be performing for whatever kind of NVMe we put into whatever kind of slot we put it into. And then, of course, we'll do sort of a test in most cases of running Cinebench to make sure that our CPU is able to complete that task without getting too hot, which in my opinion is over 85 degrees Celsius. Sometimes we put a temporary cooler, like for me to test this system when it's not installed in the case, I simply put a stock cooler on it that wasn't designed to cool a 125 watt CPU. So that's okay as long as we don't push it really hard. Doing simple tasks or momentarily little spikes in resources don't hurt anything, and then it verifies that everything's good to go to be installed. Now, if I wasn't making any videos, I would not be prepping the motherboard outside of a case. And I want you to understand that the way that I build computers on video is not the way I build computers in real life. These videos are live and unscripted and unrehearsed. So these are as close as I can get to real life. But what I can't do is I can't have you move up to the table and adjust depending on how tall you are and where you're standing to see what I'm doing. So what I'll do is I prep the board on the motherboard on the box. And the purpose for that is for you to see. If there weren't any cameras here, I wouldn't have done that. Unless I was worried that some of the parts I bought may be sketchy, because I don't want to install it and take it back out. But because I'm buying my parts from Amazon, Newegg, and other reputable sellers, and the parts I'm buying generally are brand new, it's pretty rare that we ever have a problem. I mean, it's pretty rare. Once every 2 years, maybe something's bad. But you know, for as many systems as I build in 2 years, to have one bad part, that's just very unusual and uncommon. But if I ordered something off eBay or bought something Facebook Marketplace, you know, somewhere a little sketchy, I'd probably want to prep it outside of the case. But I do want to be very clear and transparent about the reasons why I build on the motherboard box for the camera. But that if you were building at home, I would not advise you to do this with brand new parts. You should just go ahead and put the motherboard in, and you'll have a nice solid backing behind the board if you put in all the standoffs to put in your RAM and your CPU and your cooler. Because I can't put a liquid, well, I can, but it's difficult to put a liquid cooler on the motherboard and then just have the radiator hanging out. And then it makes it even harder to then install the radiator and the motherboard when they're connected together without first disassembling them. So especially when using an all-in-one cooler, it's much easier to do it. Lay the case down, work with gravity, don't work on it upright. So I need you to keep into consideration that the reason I'm building with the case upright as much as possible, and the reason, again, that I'm building with the motherboard on the box, is so you can see what I'm doing. Because otherwise, you wouldn't see anything. If I worked on this the way I normally work on computers off camera, this case will be laying down and it'll stay that way pretty much until I'm ready to turn it on. I'm going to plug the CPU and the RAM and the water cooler and the radiator, all that with the case laying down. Now, if the case didn't have sides and you could see right through, we could certainly show it that way. But understand my challenge in trying to demonstrate and educate through examples. I have to find a way that I can do that without obstructing your view. And so there are certain times, like when I put this water block on, I need to set the case down. Or when I'm installing the motherboard, I have to set the case flat and work with gravity. But then I'll try and get it upright to do everything else for the camera. So things like plugging in the USB port plugs, the front port umbilicals, it's easier to push down than to push sideways. So if the case were laying flat, even that part is easier. It makes the building process simpler, less challenging. So if you're watching these videos and you've never purchased a computer or you've never built a computer before, or if you've built by literally watching what I'm doing, that's not the goal here is to show you how the parts go in. What I would recommend strongly, you put the board in and lay the case flat and follow what I'm doing as though I'm showing you in X-ray vision what you should be doing inside of the case. Just so we're clear, this is not the normal way that I build a computer unless there's a camera on. So I'm not trying to hide anything from you, and I also don't want you to have the misunderstanding that this is the proper way to do it. This is only the proper way to do it if you're trying to teach. So with that out of the way, I think where we're at on this build with the motherboard installed, we have the front port umbilicals, we have the power supply to hook up, and we have the water block to install. Now, of all of that, probably the one that has the most pieces is the water block, but even that should be relatively simple. And this case is quite unusual in that it came with a power supply already installed. It came with a liquid cooler already installed. And so these are things that we don't have to put in. Sometimes you've seen me struggle getting a radiator to fit right, or figuring out which way the fans go, and whether I want the radiator at the top or at the front, or maybe even at the bottom. All of those decisions have been made for you. What power supply should I get? Is the color going to match? So what Cooler Master has done is quite unusual in that they've given you, it's not quite a bare bones, what we call a bare bones computer, but everybody needs a power supply and everybody needs some kind of a cooler, maybe not a liquid cooler. But if you wanted a liquid cooler, if you wanted a modular power supply, this is modular, isn't it? Yeah, I believe this is modular power supply. This takes those little bits of work already out of your build, so these things are done. The rear case fan is installed. Some cases don't come with any fans at all. Which fans do I buy? Do I want RGB fans? Which brand? Do I want magnetic levitation fans? Do I want sleeve bearing fans? For some people, that's overwhelming and they're afraid of making the wrong decision. This is all done for you. You may see that as an advantage and you may see that as a disadvantage. That's why you have options. For some people, this is the best thing since sliced bread. And for other people, they've removed choices that they would have. I don't want that cooler and I don't want that. You know, they know what they want. So this isn't necessarily for them. But do know that when you get a 360 millimeter cooler with a rear RGB fan and a power supply in a case, it will cost you on average about what this case sells for, about $400. Especially if you consider an average price of $100 on an 850 watt power supply, which is what I think this has. And it's 80 plus gold rated, which also makes it worth more money. Yeah, 850 watts, 80 plus gold. So if you just price that, that's probably at least $100. A 360 millimeter all-in-one cooler with a RGB block on it with RGB fans is probably close to $200. And the case itself with the rear fan is easily $100 to $120, $150. So you add all that up, this isn't priced so bad after all. And again, it's less work that you have to do when building your system. Now, personally, I think the work is fun. I like it. But some people see it as a chore, like just a necessity to get to where I want this amazing system, and the only way I'm going to be able to do it is to build it myself. And then they want to rush through it. They're anxious. I want to turn this on and start using it. And they don't really enjoy the build process. And I know it's going to sound a little twisted, but part of the enjoyment are the challenges and the frustrations when something doesn't fit right. And you see me on camera getting frustrated. If it was nothing but frustration, I probably wouldn't want to do it anymore. But if there was never any obstacle to overcome, I probably wouldn't want to do it anymore because it would be boring. So I enjoy those challenges and I learn from them. I go, wow, there's something I've never seen before. I'm going to store that away in my head as best I can so I know how to deal with this next time. If there is ever a next time, I don't know. But I'll be more prepared next time. And then I learned something and I enriched myself and I just grew a little bit. But if everything goes exactly as you planned, it's kind of, I don't know, the reward and the fulfillment is still there, but it's nowhere near as strong. It's nowhere near as powerful as the reward and fulfillment of overcoming an obstacle or a challenge, right? So there's a delicate balance here. No challenges, boring. Too many challenges, frustrating. Now, there are times where I might hit one challenge and then go right to the next challenge. Then I get a bad attitude. Then I'm like, you know what? At this point, I need to stop, take the day off, and come at it fresh tomorrow. And that's perfectly normal. If you force yourself to do something and you're not in the right mindset, you're probably not going to do good work. And if this is an important computer to you and you've put a lot of money into it and you're not in the right mindset, try to be self-aware to realize you're in your own way, and you'd be better off waiting until you've had some rest and had some time to think about and process, and then come back at it. And you might find, at least in my experience, it's so much easier once you take all the frustration and it sort of clouds, at least in my situation, it clouds my thinking. It's like the pathway gets narrower. I don't know how to explain it. And then after resting, that pathway opens up again, and then I can turn my head and look instead of being so narrowly, focused. And I find that's very helpful for me sometimes, because quite frankly, there's usually only one obstacle I have to get around with some build, something unusual I've never seen or I wasn't prepared for before. I always learn from it. And then generally, once we overcome that, everything else goes right in place. But every once in a while, and you've seen it here, I go from one right to the next one. And then that's where you'll see I start losing my patience. And that's when I start to be aware that I probably shouldn't continue any further because I'm not working to my quality, to my level anymore. And that's human, because I'm not a machine. And I would expect that and hope that you would do the same, because that's how parts get damaged. And a lot of times it's due to impatience. I just want to get it done. When it comes to computer builds, I hope you enjoy the build and you want it to last. Savor it. Because if you're like most of us, you can't afford to do this very often. So I hope you enjoy it, the process. And it might be a couple years before you would, have another process again, right, of building. If I had the budget for it, we'd probably be building 2 or 3 times more computers, because that's how much I enjoy doing it. But I've had to slow down, times are a little bit tougher, and I have to figure out where these computers go after they're built, and I'm running out of space. So for those reasons, you're seeing fewer builds, but I hope that they inspire you to build your own system and to know that there are many options out there that I'm here to introduce you to. Different boards and processors, different storage, different RAM, different kinds of fans and different kinds of coolers and different kinds of cases and different kinds of power supplies, that you are welcome to take each little ingredient and make your own little recipe out of it. and have something uniquely yours that you created with your own two hands, it's very fulfilling. And if you've never experienced it, I cannot explain it to you. I mean, you feel free to ask in the chat room, but I think everybody agrees it's something you have to experience in order to really understand that feeling of fulfillment and accomplishment. So that's why I keep coming back at it, because I keep getting that great feeling when I'm done. And the more challenges it has, the more sense of, it's done. That just grows, and it's even more rewarding mentally when that does happen. And while it's frustrating, it can be frustrating in the process, the reward is greater. So food for thought as we continue. Now, to put this liquid cooler on, and again, I've never worked with this case, I've not looked at the documentation. Everything should mostly be the same with regards to working from one computer to another, from one cooler to another. They should all generally go on the same. And after doing this for as long as I've done it, I'm very disappointed when a company doesn't make it, for a technical person like myself, if it's not intuitive. If I have to go to the instructions, that means that is so different that I can't figure it out by looking at it compared to all the other coolers I've installed. And that's not necessarily bad unless it's not superior. In other words, if that method is easier, or if that method cools better, or if that method is less involved. But if the method is there just to be different and they made it more complex and unintuitive simply because, then I'm frustrated because I don't understand the purpose behind overcomplicating what is pretty much should be an intuitive process for somebody who's done so many cooler installs in all the years I've done it. So what I do is I give every company the benefit of the doubt. We have the instructions if we need them. And hopefully I don't need them, that it's all going to go together very intuitively. Let's find out. So we're going to start by, again, I want to put the liquid cooler on first, put the block on, and then after that we can hook up the power cables and the umbilical cables and fire it up. I mean, that's pretty much it. So it shouldn't be too much work. Because I've never put this cooler on, I don't know its mounting system, so let's just take a look at what we've got and see if it makes any sense just by looking at it. Now, I'm not opposed to other people looking at the directions. Feel free. I've seen a lot of directions in my life, and at some point they all start getting quite repetitive, and I don't expect there to be any new information, so why bother looking, right? After 34 years in this industry, you can only imagine the deja vu I get, seeing the same instructions over and over and over with little variations here and there. But every once in a while, I still need them, and that's fine. There's no loss of pride there. It's really just about trying to get it done and the personal pride of figuring it out. Now we've got this backing plate. We've got a couple of these hose clamps or combs that keep the hoses looking straight. Those are optional if you want to use them. We have a fan splitter. 3 fans. Oh, I see. Okay, it looks like there's a fan header off the pump that's going to plug in. See, like, this is not intuitive. Why is that plug a different color than the others? Is there another opposite plug the same color? There is not. So that's not intuitive. How do I know why that's a different color? It's not explained. Nothing's written on it. I will have to go to the manual to find out what the significance of that plug is. This plug has 4 wires going into the plug, and even though these plugs can hold 4 wires, if you count them, the second plug from your left is, or the second wire from the left is missing. This has 3 wires. This one has 3 wires, and this one has 4 wires. So my guess is that the pump is going to take this color, this brown, and that these 2 remainders are going to go, because we have 3 fans, right? So we should have 3 additional connectors. This power cable, SATA power cable, likely powers... What does that power? I don't know. Because the fans should be powered through... You don't want to power your fans through a connector like this unless it's going to a fan splitter. So do we have a fan splitter? Does this go to a fan splitter? Because if you were plugging your fans directly onto your power supply without a fan splitter, they're just going to run at full speed at all times. Maybe some cheap cases do that, but a nice case, you know, one that costs a little bit of money, they're not going to do that to you. Sometimes these are there to light up lights. But I'm going to guess that there's a fan splitter, and I can, as I'm saying it, I see it right here. What's interesting is the fan splitter says reset switch right on it. That's not a reset switch. That's the button you would press to change the colors, which you wouldn't use if you use these other plugs. These are ARGB connectors. And the addressable RGB connectors are on the motherboard, and it's a standard to allow the motherboard RGB software available from the manufacturer to synchronize the lighting of the board and everything plugged into an ARGB, addressable RGB plug standard, so that pushing the button manually is no longer needed. So this used to be a reset button, and the manufacturer has said, look, let's repurpose the reset button and let's wire it to the fan controller and it can control the lights. But then they didn't change the writing on the plug. It still says reset switch, and it's not a reset switch. It's a repurposed reset switch from a previous case design that they've repurposed. So that's why they did that. It's very strange, right? And on the fan controller, it looks like the fans are already plugged in for us. It appears, yeah, it looks like this ARGB header had come off. We'll put that back on, right like so. Right like so. Okay, and so I'm guessing this big connector right down here, this is the SATA power cable. And then one of these ARGB headers needs to get to the motherboard somehow. They're not very long. There's this one. We have a couple of ARG. We have 3 of them. And because they're plugged into the fan controller, they will not plug into each other. They're meant to plug into something else that has a ARGB. So I'm still confused what these other 2 connectors are for. So if one's going to the block, well, I suppose I just need to look at the power cables here. So part of what's in this wiring harness, or what they've wire tied together, is an ATX 3.0 graphics card power connector. Because we have no intention of putting one of those in today, but we might in the future, we can just get that out of here, and that removes a little bit of chaos and noise, making what we have to do a lot more clearer. And we have that 4-pin connector here and the ARGB header here. So again, I'm just not sure what this does. So we're going to look at the documentation. Usually if there's a different color socket, there'll be a different color plug, and that's how you know those 2 things go together. It's literally that easy most of the time. And normally a button that controls the lights won't say reset switch on it. Like, it literally says reset switch on the plug, because they did not change that in the manufacturing process. But it appears you can change this back to a reset switch. Even though it's got a picture of a light on it, the instructions are saying if you want to, you can take the reset switch wire, and instead of using it to control your lights, you could use it the way it was originally intended from its original design before RGB, and that is to just plug it into your motherboard's reset header on the motherboard. So that is an option, and they did, I suppose, leave it labeled as reset switch because it's still a reset switch if you choose to use it that way. But it's got to be one or the other. You can't have both. You'd need another separate button otherwise. All right, let me get to the cooler. Cooler. This is just cooler mounting, which is pretty standard stuff. What I'm looking for is the cooler wiring and where that splitter would be used, in what scenario. There's no words, it's just pictures, and so they're showing a description that I guess is open to interpretation because it's not explaining what's happening here. Gosh, that's really strange. There is no written documentation. It is just a book of pictures. And I'm usually good with that. Sometimes the first page of the manual will tell you everything that should be in the box. This is an itemized list of every piece that you should have and what those pieces are called. So sometimes you can look at what they're calling that and from that infer what it's intended for. So here it is. It says 3-to-1 fan splitter. And it says it's used for connecting multiple fans. Who would have thought? What fans are they referring to? Additional fans or the fans already there? They're not clear. Maybe I'm too literal, but I don't think we're going to need this. My suspicion is that this is if you wanted to add additional fans, and we have run out of space on the fan controller. And you could add fans up on the top if you wanted to, for example. There's no place for fans on the bottom so far as I can tell. So I don't believe we need this for our build. I think this is if you're just trying to add more, and this accommodates that request. Now, the socket, I hope, is going to be compatible. I think it should be fine. We've got a modern Ultra 7 Intel board that uses socket 1851. And when we look in the documentation for what sockets this supports, right on the back it says LGA 1700, LGA 1200, and LGA 1150, whatever, 56, 55, 51. It's a little X, and the X is a variable. Nothing about socket 1851, but socket 1700 and 1851 should be identical and compatible. So if we follow, and again, you wouldn't know this if you're a first-time builder necessarily, that you know, this could be a stumbling point where you go, well, that doesn't cover my CPU socket's not mentioned in here. Over time, as inventories get updated and instruction manuals go out, it'll likely just add the 1851 onto it, but I don't think they need to address anything other than confirmation. Yeah, so these directions are basically the same as every other water cooler we've installed. From what I can gather by looking at the pictures, we're going to install the bracket, and the bracket needs to be in the socket 1700 position in order to line up with all the holes. And it may have come out of the box already aligned for that config, or in this case it didn't. The pins are adjustable. They can move in and move out on an angle, and that's to adjust the size of the socket. The newer CPUs require sockets that are larger because the new CPUs have added pins. That means they have more connections for more lanes of traffic and more data. And so the socket naturally gets bigger. They don't get smaller. We went from socket 1100 to socket 1200 to socket 1700 and now socket 1851. Bigger and bigger and bigger. The good news is those pins, those connections between socket 1700 and socket 1851, that's a difference of only 150 pins. And they're little teeny tiny pins, and that's why the difference is relatively minor, and it only requires you to adjust the screw location on the bracket versus here's a bracket for one socket, here's a bracket for another socket. You can imagine the cost of manufacturing and the cost of the cooler would go up, and then you'd have all these extra components you'd be throwing into the recycle bin that you just purchased that you will never use. So the way we adjust these is we want to make sure that we're in the outermost position on here. Oops. And it looks like there's only two positions. Looks like innermost and outermost. And the way that you adjust, if I bring this up to the camera, hold on a second, let me bring up, there we go. All right, now I can see what I'm going to show you here. Close up, we have this little plastic cover. And if you've watched my videos, you've seen the same design from other manufacturers. This slides off and it exposes, in this case, a small, funny looking screw that has a weird rectangular end with no threads. And that is going to recess and lock into place so that it won't spin when you tighten it down. And you'll see the hole is oblong, meaning that that screw can sit up at the top part of this oblong hole or the bottom part. And we want it on the top part. And the way that we do that is simply install the screw, and you see how the head of the screw is going to sink in right there, and that locks it so it won't spin. And then you take that plastic cover, and the plastic cover will keep that screw from moving just like that. And what it's done is very subtle, but now that screw is further towards the corner than the other three. We have to repeat this on the other screws so that they're all the same. And then it should line up with the holes in the back of the motherboard on either socket 1700 or 1851. It also appears with this design that removing that plastic cover isn't entirely necessary. It looks like the plastic cover moves all by itself so that the installation isn't as aggressive as what I did. So I'm realizing now all I have to do is move that and it clicks. Now we've not seen that from other similar looking designs, but this is a smarter design. Click, click, click. That way you don't have to do what I just did. And then where it's clicking is on the other side. There's these little grooves, and that little tab, when you move it, goes into the groove, and that's what you're hearing click, and that's what holds it there. So we want everything out at the far corners, and that's how easy it is. I was doing it the hard way, and now I've learned something new about an installation process I haven't seen before. Or if I have seen it before, I haven't seen it in a long enough time that I forgot. So either way will get you there, but that's a lot easier. And then now it should just fit within the holes around the CPU socket, and it does. Now this part can be a bit challenging. There are some brackets that have tape that will tape onto this metal plate and hold it in position as you put the standoffs in the other side. Because if I let that go right now, it's gonna, want to fall out with gravity. If we bump it or anything, it'll just fall out. So usually you got to use one hand to hold it in place. Whether you do this with the case lying down or with the case upright, it's a challenge either way. But I try to avoid touching any of the metal behind the motherboard. But the metal on the motherboard tray is completely safe for you to touch that. So if we're touching everything that's plastic like this frame or the metal beneath that frame, we're okay. But the little tiny solder points and the little circuitry, you want to keep your hands off of that, because that's where an electrostatic discharge can affect and damage the board. It's highly unlikely when parts are soldered onto a motherboard that electrostatic discharge is even a thing. When the parts are at the factory and they're being handled before they're installed in a grounded circuit, this motherboard is a grounded circuit, as any circuit should have, they're really susceptible to ESD. But once they're mounted and soldered in place, they're still a little susceptible to ESD, but it's pretty difficult, like I said, because once it's in the circuit, it's already grounded on the circuit ground. So regardless of that, you see I don't wear an electrostatic discharge strap because I find them confining. And as long as you don't touch anything that electrostatic discharge could damage, like it's not going to damage the case, it's not going to damage the motherboard tray. As long as you're mindful that you'll handle the parts by the edges or by plastic pieces or metal heat sinks, and keep your fingers off with the actual components, it accomplishes the same goal. But, you know, I'm not suggesting you do it one way or the other. I'm explaining to you there are options, and for you to choose the one that fits your specific concern. Now, with that piece installed, I have to use the standoffs to secure it. Now I've got all of the parts. This other bag is all for hard drives. We're not going to even use anything in here. So as far as I'm concerned, and again, just to make this a lot clearer and less, look at all those parts, you know, it could be intimidating. Let's see, this is for a graphics card. We're not using that. And I don't think we need this. So suddenly, when the table gets clearer and there's not so many parts, this job doesn't look anywhere near as intimidating for a beginner. So we've got this bag that has thermal compound, and it looks like Cooler Master's given us a pretty large syringe of thermal compound, although I suspect it's probably only filled down here towards the bottom, but it's impressive looking. Certainly better than a little baggie that you have to cut open with scissors. I hate that. It's so cheap. So this is good. Now again, the case manufacturer or the all-in-one pump manufacturer, who's the same here, they don't know if you're building an AMD socket AM4, if you're building an AMD socket AM5, if you're building an Intel 20 series or 20X 2000 series chip like Xeons or the Core X series. They don't know if you're building a socket 1200, 1100, or 1700 or 1851 socket Intel. So they give you all the parts to universally make that fit. That means you're going to have a lot of parts left over. Any part that's labeled for AMD, we're not using on today's build. We'll probably never use it, but it's up to you if you want to save it in case you decide to upgrade or change your processor out from AMD to Intel or Intel to AMD. In this case, because we're installing Intel, anything that says AMD on it, we will not use on today's build, and it's simply included for other people. It's not included for you. This says sockets 1200 screws. We won't use that. This says sockets 1700, 1700, and 1851. Use the same screws. This says Intel brackets. This says bracket screws. And this says these are the thumb screws or the nuts. That's it. That means all of these parts in my hand will not be used on this build unless we change the motherboard. And that assumes we're changing motherboard because we want a different type of CPU. So if you feel that that's a potential in your future, and when you do that, you still want to keep the cooler, you're going to want to put these parts away. So I'm going to just put them here in the motherboard box. And once again, as we remove parts that we're not using, it removes the intimidation. Suddenly the job doesn't look so overwhelming. Simply taking this out of the bag and getting rid of the bag, all of a sudden space is opened up. Now we've got 4 bags. It's pretty easy to me. 4 bags, that's nothing. The bags aren't full. This bag has 4 screws. This bag has 4 standoffs. This bag has 4 screws. This bag has 2 brackets. You go 1 bag at a time, and before you know it, you're done. Let's start with what they're calling the LGA socket 1700 screws. I think that's where we start. Yes. Sounds good to me. Again, I'm trying to be as intuitive as possible, and I'm picturing in my head how these go on. They should go on like every other third-party cooler we've ever installed. With a few exceptions, they're mostly the same. We're going to take this tall, it's kind of a thumb screw standoff built-in one. So there's no washers we deal with like we do with others to build them up a little taller. They've already done that with the 1 screw. This screw is going to provide us 2 purposes. One, it's going to hold that bracket on from the other side. That's what the hole is for. And in the screw that sticks up, the bracket's going to sit on that. And then that's what's going to lock our water pump to the top of the CPU, and we're done. It's really that simple. So I'm going to hold that in with one hand, and I'm going to come around to the other side, and I'm going to start threading this onto one of the screws. Now, don't over-tighten your coolers. I can't stress this enough. The reason why this isn't in the shape of a nut is they don't want you to use a socket or a wrench. They don't even want you using pliers. You just tighten this onto each post by hand as far as you can tighten it with your fingers. Don't go any further than that. Don't leave it loose either. So what we do is we get all of these started here, and I realize you can't see, but the problem is if I turn this around, then I can't see, and then how can I do the work if I can't see? We're going to address bringing back the close-up camera soon enough, but in the meantime, I will show you the results here in just a second as I put the last one on. Now at this point, we just want them on. We don't have to tighten them. We want to make sure that we have no issues getting them threaded on, and make sure we thread them on enough that they're not going to just fall off. So I'll turn it quite a bit. And now I'm going to show you what that looks like, which hopefully, and again, I don't know how well the camera is going to pick that up, but if I shine the light in here, there's a, sometimes the light makes it worse. In the corners are where I've just placed those. And again, if I did it out here on the box, you would see this much more clearly. With that done, I'm simply going to now finalize those by going to each one. Oh, see, now that one, that was a lot looser than I thought I left it. And I'm going to get it as tight as I can get it with my fingers without hurting myself. And I'm going to go back over them, and it doesn't matter what order you tighten them. They're always going to have some play. This should move. In most cases, when you put the bracket on, the bracket is going to move a little bit. And what happens when we sandwich the cooler on, the screws on the cooler pull the bracket towards the board, and the board is like the meat in the sandwich. And that's why this bracket stays loose, so that it can adjust forward as needed to achieve the proper amount of tension between the bottom of your cooler and the top of your CPU for the most efficient heat transfer possible. The amount of pressure is designed by engineers. It is designed by not only the engineers of the CPU, but the engineers of the cooler to meet within the range of acceptable minimum and maximum pressure. If you put too much pressure on it, you bend and warp the CPU, and then the top of the cooler is now sitting on a CPU like this, and this end of the CPU is no longer under it. You would need a microscope to see. I'm exaggerating the difference. But the idea is the flatter the two surfaces are and completely touching, then all the heat off of this surface gets transferred onto this surface, and then it gets transferred into the water, which goes through the radiator, and then the fans, just like on a car, blow through the radiator, cool that water down. It's not water, okay? It's they call it a water cooler. It's not water. Water's in it, but it's more similar to antifreeze in a car. It'll have a much higher boiling point than water does, and it's not safe to drink. It's a chemical designed for efficiently dissipating heat. It's also, unlike water, it's not going to build up, it should not build up corrosion or bacteria, which a lot of people who build their own coolers, they do their own open loop cooler, need to flush and clear their coolers every year because of the bacteria buildup. You're not going to have that on a sealed factory cooler. There's no maintenance on it. You use it, it will eventually fail for one reason or another. Some manufacturers, it's been reported that their coolant was inefficiently filled or had materials that corroded the internal components. That's not normal, right? That's a defect in the manufacturing process. I know Enermax had sent out brand new coolers to people, because I got one, who bought a previous model that was known eventually to have corrosion issues, which led to cooling issues. And the problem was the formula that they used for the coolant. That was addressed, and new units were sent out to those affected. However, that's not normal. It's very rare in the industry. And if you buy like the cheapest cooler you can find from some manufacturer you've never heard of, you'd be more likely to experience that. Not going to say you are going to experience it, but your chances are much greater than dealing with a big name brand manufacturer. Because that costs them money and it hurts their reputation if you're a big name brand manufacturer. And I can tell you that the Kraken cooler that we have in the old Streamer works great to this day. The Asus cooler that we have in the Streamer I'm using now, it's still fairly new, maybe a year and a half old. Silent, runs great, CPU stays cool. In fact, the Thermaltake cooler that we removed from the Apache helicopter build that's over 4 years old still works perfectly fine. And it's impressive how cool it keeps that 10900K. I don't think it broke 74 degrees in a Cinebench test, which is outstanding. So the coolers are made better today than they were made years ago. So what you learned to be aware of back then has changed. And while some of that still exists, it exists primarily from the Asian manufacturers that you're buying off AliExpress or some brand you've never heard of. It doesn't mean they all have that problem. It means that if you're going to experience that problem, it's more than likely going to happen from one of those lesser known brand names that sells at a discount price, statistically speaking, than it's going to happen with a big name brand. And so when you're looking at the price, you need to consider, do you want the peace of mind of increasing the likelihood of a longer lasting cooler? Or would you rather save the money today and deal with that down the road if it happens on a no-name brand cooler? There's no right answer here. It's just about being reasonable in what you're buying and understanding what the pros and cons are each way. The con on a name brand is it's going to cost more, but the pro is it's statistically going to last longer. The con on a cheaper one is that it may not have any warranty and it may be made of lesser materials and not as high of quality, especially when we talk about coolant or even the pump motor. But then the pro is it could cost half as much or even less. There's no right answer here. It's just whatever you find acceptable is the right answer for you. Now, once we've got this bracket on, the next thing is we have to figure out a way that we're going to attach this to that. So that's where these little brackets come in. It says 2 Intel brackets. And these brackets attach in 2 places. They attach to the cooler and they attach to the bracket, to the support bracket that we just installed. This is what brings everything together. Now, Intel brackets are a different shape and length than AMD brackets, so if you've got the wrong ones, it's just not going to fit. It should be pretty obvious. What's interesting is there aren't different brackets for different Intel sockets. So while there are different screws, right? We have the LGA 1700 for Intel brackets. For whatever reason, apparently in engineering, all of these brackets are the same shape and length for all of the Intel sockets supported by the cooler. So 1100 and 115X, 1200, 1700, 1851 all use these same two brackets. So I'm going to guess when I'm feeling the bracket, there's a ridge, and I'm going to guess that that's what holds the screw in. So the screw probably goes in from the smooth side, but I'm not sure. And then you got to say, okay, well, do the brackets, these are going to go on here. Do these go like that, or do they go like this? Now, sometimes there's a separate bracket on the pump, but this pump has nothing. So what my guess is, because of this design, is you put on the Intel or AMD brackets on the pump first. And I think, and again, you've got to consider where your hoses are. You don't want your brackets to get in the way of the hoses. But with Intel, it's sometimes a little bit confusing. If the brackets are completely square, then they can go on any 90 degrees. AMD, they can only go on at 180 degrees. It's one or the other. So because I'm not familiar with this cooler, my guess is I see a couple of notches cut out on this side of the bracket. That's usually to make room for things like cables, for example. And then I look for where the holes are and where the holes are on this and where they would line up. And I will tell you whether or not this bracket goes this direction or this direction, whether it goes from 90 degrees by the hoses or 90 degrees from the hoses is not clear to me. There's no clear path here. Then I have to look back at the documentation and hope that the pictures are clear when it comes to which way these face. And I suspect that should be clear, but let's take a look. Okay, for an Intel, okay, here's what it says. And this is not that unfamiliar to us. There are slots carved in beneath these two layers of plastic. And the idea is that this would go into those slots. And there is a groove that it looks like the part that I said sticks out. That's apparently what the grooves are for. But then does it go in this way or does it go in that way? That's the question. I can put it in like this or I can put it in like this. In either case, those grooves are sticking out towards me regardless. So then I got to pay a little closer attention to our documentation and see what orientation they show that going on. So they show that the legs on this bracket go away, not towards. They don't bend in towards the cooler. They don't wrap around it. They stick out away from it. Those little details. And again, without any words, you just have to look at the picture closely to determine. Like, for example, I'm going to show you how you interpret these pictures. It's kind of a fun little game. Let me walk up here. Because we're looking at step number 8. Okay, so step number 8 is saying those brackets, see, it doesn't even show you putting the brackets on. Those brackets, I want you to pay attention to which direction the legs of the brackets come out away from the cooler. And then where are the hoses on the cooler? Do you see the hoses? In proximity to where the brackets are. Hoses are right back here. So the brackets do not go underneath the hoses. The brackets go to the left and to the right of the hoses. But all of that is conveyed in this one simple photo that you're supposed to look that closely at in detail. So it's not difficult to understand. There's a lot of information being conveyed there, but you might have seen that picture and went, what am I looking at? It's a cooler going on a block. Yeah, but look, pay attention, because that's showing us in proximity to where these hoses are. These go to the left and to the right. The notches that are at the top of the block are clearly for the extensions here, the ridges of the screw holes that extend past the bracket, versus on this side, the bracket's completely smooth. So they're clearly making clearance for those notches. And then these legs, they go out away from the block. So that just sets in there very gently. There's no click or locking that in place. So how does that stay in place? Well, and this is where we go back to intuition. There's going to be some little tiny screws. That's this bag of screws right here. And each bracket has 2 screws, and there's 2 brackets for a total of 4 screws. Now, I've never seen screws that tiny. Well, let me rephrase. Lately, I haven't seen screws that tiny on a cooler install. For many cooler installs, this piece is already done, or it's a U-shaped piece that slides in and locks in without any screws necessary. Again, these folks sue each other when they copy each other's designs. So everybody's got to make enough change to keep them independent to avoid paying royalties to whoever did it first. And that's why there's a variation in the cooler installs, and why so often I don't need to read the documentation, because it becomes, you know, again, after you've done a few of them, they all sort of have, you understand what the goal is. Okay, we're trying to get this on the CPU, and that it comes with all these different brackets and standoffs to accommodate all these different kinds of CPUs. If they didn't do that, you'd have to be very careful over which cooler you bought to ensure that that was the right cooler for the motherboard or the CPU that you bought. That means there'd be a lot more returns, because people are like, oh, I thought they were all the same. So to avoid that and the cost of manufacturing and labeling the boxes, they just go, look, here's everything you need for 6 different types of CPUs from Intel and AMD. You're going to have leftover parts. And it's really simple. Again, the first time you do anything without any point of reference, it could be a challenge, and that's okay. But then after a while, it all starts to kind of come together and make sense. And then all you need, like in my case, all I need is a little hint. Just point me in the right direction. Now I understand. We secure these screws down, and that's going to lock the bracket in. It needs to be secure on this design, because that's what's holding this block onto the top of our CPU. And if it fails to hold it tightly, we're not going to get good cooling. But what you don't want to do is you don't want to over tighten, and I can't emphasize that enough. You bring it forward and it'll start to lock in. But if you start to feel your screwdriver slip, either you're over tightening or you've got the wrong size screwdriver. Now, some coolers include a screwdriver to help avoid that from happening. This one didn't. The driver I'm using is basically like a Phillips #1 or a JIS. This one's a Japanese industrial standard #1 driver. It's a little narrower. I suspect either one would work well. And then we're simply going to do the same thing on the other side, paying careful attention that the little extension here that comes out, almost like a nipple that comes out, goes underneath those ridges or notches. They will face away from each other. I put that on 2 different ways wrong, made my corrections, slide it in place. It does more or less hold it there for you. It's not going to fall out, but the screws are what secure it, and that's a critical step you don't want to skip. These screws already have a little Loctite on them, and that should prevent them from vibrating loose over time, and that's a nice touch from the manufacturer. Once again, cheaper coolers from lesser known manufacturers bought from places like AliExpress, Temu, probably don't give you that kind of consideration. So you could end up with a cooler that's, less than half the price, but that keeps loosening on you over time, and you have to keep tightening it. And if you don't know any better, you just might think they're all that way, right? You may not know that, hey, that's not normal. And of course, you could also provide your own Loctite if you're so equipped. This is all done for you, so you don't have to do as much. It's all included in the price. So as you can see, this is a little bit more time consuming, putting the cooler on, but you only have to do it once. So take your time and enjoy it. That's on pretty tight. Now let's test fit it. Usually the hoses go towards the RAM. Usually. Sometimes manufacturers change that. And the way you can tell is where the logo is. Remember, some of these liquid coolers have RGB and writing on them that's etched in. And if you look very closely, like at a lot of Thermaltake coolers, for example, or EKWB, they have a logo. And the only indication you have as to which way is up, I mean, the logo is kind of a vague outline. And I don't know, is that outline supposed to be vertical or horizontal? Should it be at the top left or the bottom right? So I'm looking at this cooler, and I see the word Atmos is written here on the bottom. But I see the Cooler Master logo is sideways, which is weird. Normally, the Cooler Master logo looks like this. And so the question is, and I don't think this lid comes off, sometimes these rotate. I don't think this one rotates. And I think aesthetically, the cooler is going to work the same no matter how we install it. If we install it with the hoses straight up, so we see the word Atmos, with the Cooler Master logo sideways, or we rotate it to the right, then the hoses face the RAM, the word Atmos is sideways, and the Cooler Master logo is now correctly oriented. I wonder what the documentation recommends for aesthetic. This is purely for looks. Again, if we look at, and I want to show you this detail in the photo so you understand how to interpret these photos. If you want to do it the way that the documentation recommends, the hoses on the Intel base, they're opposite of the RAM. They're right up against the RAM. What's interesting is if you look at the AMD install over here on the next page, the hoses also go next to the RAM. So they're staying pretty true to the orientation. And what that means is this word Atmos that's written down here is meant to be sideways. And the Cooler Master logo is meant to be right side up. That makes sense to me. Company logos are usually like the most important thing to the people, the managers and the department heads want to prominently display that logo. And then any sort of product name, well, just slap it on there and put it sideways wherever it'll fit. That's pretty common. So let's test fit what this is going to look like by simply placing it over the posts. And you'll see the hoses are going to go a bit over the RAM, and it may be possible for us, not so much. This is an unfortunate consequence of the RGB RAM and the big case window, is quite often when your hoses go right next to the RAM, they kind of block the RAM out a little bit. They go over the top of it and detract. So you may choose to turn this around this way. Now, you're still going to go over the RAM that way. We could turn it around and face it upside down. The problem with putting it upside down is now all of the cables that we have to hook up are all coming out down here, and we need them up here. So now, while we've cleared the hoses of seeing the RAM, we now have to route cables back up, covering up other stuff. So one way or another, you're going to have to pick which of those you prefer. I'm going to stick with the default of what the manufacturer recommends because their marketing company trust me, it's a marketing decision, has decided that's the best way it should go on aesthetically. And since marketing people understand all the psychological manipulation of the images, I'm going to go with what they say. I'm not going to try and outsmart them, but the cooler will work the same in any orientation on an Intel cooler. It's just what you personally prefer aesthetically. If I buy a cooler that's got words on it, like thermal take, I want the words to be facing properly in the right direction. I don't want them sideways, and I certainly don't want them upside down. So if you look at the thermal take cooler, it's got two T's on it. Well, those T's don't look like the letter T if you turn them sideways or upside down. In that case, it's an aesthetical, for me, critical of importance that we get that on the right orientation, or the two T's don't make any sense. What is that supposed to be? If somebody's, is that, I don't even know, is that directing traffic? What is that? You turn it, think, oh, it's the letter T. I see. So it's those kind of aesthetics when you have a glass window. These are things we didn't worry about before the whole glass window craze. And it's part of the way the PC building has changed, where now people are trying to make the inside of it glow and showcase it through a window. And now we're making decisions in building that we never had to make before, because usually you'd put the lid on it and the lid was steel. You can't see through it. And everybody was happy. Now, customers want to see it. Many home customers want to see it. Most business customers don't want to see it. And those who want to see it get a case that they can see through, and they're buying components that cost more so they can see it better. We didn't need to put a liquid cooler to cool this chip. We could have used an air cooler, but it's nowhere near as aesthetically pleasing as a liquid cooler. So the reason we're buying it is not about what's the best component for the computer. It's what's the best component that will not only cool a computer, but also make the computer look cool. Just a little bit how the industry has changed. I'll be more than happy when that trend goes away. Let me see what you guys have been saying here in the chat room, because I've not been paying attention. Oh, a lot of activity in there since I last checked in. There's Planet Cryos with a $5 super chat. He said, "What's a guy like you doing in a place like this?" Good to see you. Good to see you, my friend. Carry on. Right on. What am I doing? I own the place. What are you talking about? It's the most clever response I could come up with. Thank you, Planet Cryos. Good to see you. Nick Caffrey joins us and says hello. Harry Thor contributed 10 Canadian dollars. He says, "I'm sorry I can't be here as often, but I do enjoy tuning in when I can." Well, thank you for your support, and we're glad to have you here. When you can make it, we're always happy to see you. Thank you for joining us, and thank you for your support. Davis Parsons confirms to me that that fan splitter that I put in the box earlier came to the same conclusion I did. Splitter is not needed. I concur, Davis. Thank you. Eric Randall said he's joining us from Texas. Hey, Eric, welcome in. Rick wants to know if there'll be color on the water pump. Yeah, if you look at the links for these parts in the video description below the video, the pump has RGB to match the fans that were all included and pre-installed on this case. And they'll all synchronize together with the ARGB header. Yep. Nick Caffrey contributed €5. He says, "Hey, Carey and Mara and chat, I arrived late and I am catching up." Welcome in, Nick. Good to see you. Thank you for your super chat contribution. Barry Klein joins us and says hello. See, Sean Gallagher's joined us and says hello. Kelly Stewart says, I just wanted to say hello before I go to bed. Having to go to work tonight. I'll work in that third shift. Hey, Kelly, good to see you. Thanks for popping in. Get your rest. And we'll look forward to seeing you on a day where perhaps you're not working that graveyard shift. I think Kelly's a lot like me. I think we're both night owls. I don't think that's torture for Kelly to work the night shift. I think he actually prefers it. I think we're very similar that way. And the great thing is night shift often pays better. Most people don't want to work it. I love that I get out of the Arizona heat and get out of the Arizona traffic when you don't go to work at the same time everybody else does. Mecca Cameron says hello. Todd said success is emotional. Oh, very much so. And it's a good emotional, for sure. Nick is talking to Mecca Cameron, explaining where he lives in Ireland, and it's... I don't even know how to say that word. Corundahill? I'm sure I'm way over pronouncing that. Over enunciating. He says he lives off a mountain and they've had to rescue a lot of tourists off of that mountain. It's dangerous. Hold my beer. Johnny says that PC is going to fall off that bench. We'll agree to disagree. Let's see what happens. Jean-Guy Gravel. OmniGuy says LOL to something somebody said in the chat. Johnny says he's been watching since the days where I was in the kitchen with the two dogs back in 2008. Yeah, that's when I started the channel. I think it was like January of 2008, 15 years ago. Yeah, you can literally watch me age. Look, he's young. Look, he's getting older. His hair's falling out. Yeah, well, how are you doing in those 15 years? Let's see. Scrolling down here just to get caught up. Ken Musetic says hello. Davis Parsons said the all-in-one cooler in this case keeps an i7 1307K below 50 degrees Celsius. That's impressive. Richard DeFries joins us and says hello. Nick Caffrey says the mountain is pronounced Corundahill. Corundahill? Phil Stodd mentions, and me, we're having to wear glasses that I didn't have to wear 15 years ago to see things, see little things. Yeah. Oh, no, no, no. Maros want to put a picture of us from 1997 in the forum. You just want to make me look older? Mecca says the only thing I see different is he stopped wearing the bowling shirt. So times have changed, right? The society and our culture has changed to the point that getting dressed up to go on video was a thing because video wasn't so ubiquitous and commonplace. It was special. People used to get dressed up, and I don't know if you remember this, but if you were going to go on a cruise, like if you watched The Love Boat from the 1970s, everybody's very finely dressed. We're going on a cruise. Again, in the 1970s, if you were going to take a flight, get on an airplane, like TWA, you dressed up. It was a special occasion, and you dressed for it. Videos are not special occasions anymore. Literally, people turn on their phones and they broadcast while they're sitting on the toilet. So a lot of that, what made it special, has gone away. You know, similarly, when bands started playing rock music, they were usually dressed quite finely. And in the late 60s and early 1970s, the rock star said, I'm not dressing up. And yet, some still did, right? There's no sort of universal, you do whatever you want as far as like how you want to present yourself. Robert Palmer, famous singer in the 1980s, would always wear a suit and tie. He was always very much the group ABC from the 1980s always wore a suit and tie. Spandau Ballet from the 1980s, suit and tie. But other bands, t-shirt, long hair, torn jeans, right? It's all about the image you want to convey. If you're being rebellious, or if you're trying to fit in to the cultural norms of society. And when I first started, those videos were intended to be to what people were expecting to see on a educational video. Teachers that I grew up with going to school often wore a tie. The male teachers would wear a tie. They got dressed up to go to work. Today, it's much more relaxed, and it also might be at Phoenix. You don't often see people wearing ties in 110 degree plus weather in summer in Phoenix. It's well, it's quite dangerous, quite honestly. But the culture is a bit more relaxed. And if you go to Hawaii, you know, people are wearing floral shirts that pretty much look loud and busy. Anywhere else, but in Hawaii it works because of the culture of the people. But you take it and wear that same shirt somewhere else and you're going to stand out. So yeah, that's why it's changed. I still have the bowling shirts. There's no, kind of need an occasion to put it on. I just want to be comfortable, and this is how I choose the clothes I wear to be comfortable. Some people wear clothes because they want to look good. If I look good but I'm uncomfortable, it's not worth it. Not for me. If I'm comfortable and I look sloppy, I don't care. Unless it's a job interview. All right. Mats Olov joins us and says hello from Sweden. Welcome in, Mats Olov. Luke Greeny wants me to check my phone. Oh, thank you for the reminder, Luke. Where's my email? There it is. You know what? I don't see anything in there yet. If you said something, it might take a couple minutes for that to process. But regardless, thank you as always. And yeah, have me check that in a few minutes. I'm sure it'll appear. I guess we could get back to what we're doing here. So at this point, all the hard work, like figuring out what the orientations of things are, we already know what our path forward is. Just want to take a little break to talk to you guys for a minute, and then we can focus. Back over to this. Now, this doesn't have to be used. This little piece here, what's interesting is it's kind of serving two purposes. What this is doing is it's protecting the surface here, the mating surface, from getting any dust or oils from your skin on it. And then they're providing these holes so that you put the thermal compound, just smear it all like a stencil, and then peel this off, and you have this really neat honeycomb pattern, which they are suggesting eliminates all of the anxiety about how to properly apply thermal compound. Depending on what video you watch and when you watched it, a creator might tell you to make an X or to use a P-shaped, a P-sized center on the cooler of the thermal compound. They might tell you to make a couple of lines or a zigzag or to put dots. None of this matters. I prefer to use a nitrile glove and coat the CPU. And I'm not going to use the stupid stencil. I think this is theater. This is when you put your thermal compound on the cooler. If we take this thermal compound and place it on here, and we peel this off, we're going to have this pattern, this nice clean hexagon pattern that you're just going to smash into the CPU. It's theater. It's a psychological marketing gimmick. It doesn't hurt anything. It's not worse than the way I'm going to do it. And it's not better than the way I'm going to do it. And it's not worse than drawing an X or a few lines or putting dots or however you've seen people do this. This is purely psychological. And if you don't believe me, try using this and put your cooler on and measure your temps. Then clean off the CPU and the block and apply it any way that you choose that you've seen from other videos, including myself, and then run the same test. And knowing that the temperature of your room is shifting up to 3 degrees one way or the other, you've got a margin of error in your readings of about 2 to 3 degrees. So if you're only seeing a 2 to 3 degree difference, that's likely just margin of error for the room temperature. Which means, at the end of the day, how you apply your thermal compound really isn't all that important. You've got to remember to put it on. Don't put on too little. If you're putting on so much that it's oozing out the sides, it just makes a big mess. And if you want to put it on in the honeycomb cutter because it makes you feel good, well, that's what it's for. Feel good. I feel better. Instead of trusting that this is going to spread out properly, I feel better manually putting my thermal compound on the CPU heat spreader so I can ensure the entire thing is covered evenly from front to back. Or not front to back, but top to bottom, side to side. And I'm going to leave this clean. I'm not going to apply it here. If this thermal compound was already pre-applied and all we had to do was peel this off, and when we peeled it off, thermal compound was in that pattern and maybe they had a little plastic cover, I'd leave that alone and just put it on. But if I have to put it on, I'm going to put it on the CPU because that's what we're trying to cool, not this. So either way, at the end of the day, it's all going to work the same. For the sake of consistency, I'm going to do it the way I always do it. So for that, I need a nitrile glove, which I have right over here. And I always prefer to use the included thermal compound. I always have extra thermal compound that I will use, not to blend, but rather to replace if this is bad. If there's either not enough in the tube or it's really hard to get it out of the tube and it doesn't spread nice, I'll use a paper towel to wipe it all up. I'll use isopropyl alcohol to clean it, whatever I'm putting it on, get it nice and clean again. And then I'll use my own thermal compound, but only if the included thermal compound is inadequate. Now from Cooler Master, I'm assuming the thermal compound should be great. The difference between thermal compounds is negligible. If you want to spend a ton of money on an expensive thermal compound, and again, I encourage you to run before and after test, you'll likely find a margin of error that makes any difference nil, just zero, completely the same. So why spend money you don't have to spend to get the exact same results? Especially if you're building 100 computers, and then of course that's going to add up real quick. So we have seen coolers like the ASRock cooler. In both cases, the included thermal compound was dried out. And as it came out of the tube, it came out okay, but when I tried to spread it, it rolled around in a ball instead of working more like an oil paint or a finger paint. I want to see it go on like paint, not like clay. If it feels more like clay than like paint, it's old, throw it away. Clean up the surface, put it back, to trying to get it look nice and clean, and then get a fresh tube of thermal compound, which is what this should be. Let's find out. Now, normally, again, I would lay the case flat, but for your benefit to see what I'm doing, we'll do this sideways. Right, the motherboard is I think, so what I've done, and I'm just guesstimating, that should be enough. And I've got that line there, and I'll spread that out to cover the entire surface of the CPU. You guys see that? I grab a non-sterile, powder-free nitrile, not nylon, not rubber, disposable glove. And instead of using some kind of tool or spatula that you have to feel through the tool, I want to feel it with my finger. I want to feel that thermal compound easily spread. And if it's too dry, it's going to ball up. This is on the edge. It is spreading, but it's doing it. It's giving me a little more resistance, so I feel like there should be more moisture in this. So what I'm going to do is I'm going to use a little bit more of it, because I think it'll be okay, but I haven't made up my mind yet. Before this is done, I might just say this is not good enough, but so far we're right on the edge. It's kind of balling up a little bit, but it's still letting me spread it out. And the more I use it, the more I have on my glove than what I have on the surface of the CPU. So this feels old to me, this tube. And the tube may have been made at a completely different time than everything else in the box that was included with it. So I'm going to use a little bit more. And maybe that's why they give us so much. Maybe it's intended to be that thick for that honeycomb treatment. But that makes me even be more concerned about that than I was before. Because it might be harder to tell. Okay. So I have decided now there's no way I'm using this thermal compound. The more I put on there, the more it balls out like clay and sticks to the finger. And I have clean, empty bald spots on the CPU. That's not normal. That's not the way thermal compound that's fresh should spread. That is an indicator that you have old thermal compound. You can still use it. It will still transfer heat, but it's not going to be, it's going to dry out sooner. And when it dries out, if it leaves cracks and gaps in the cooling in the future, you're going to need to replace it. That's not normally something that should happen for like 10 years. To see it brand new out of a tube, I wish these tubes had dates on them. I'd like to know when this was packed. Because one of two things happened, in my opinion. Either the formula's wrong, and they have a bad lot, or this tube was made years ago, and it's left over, and they're just using old inventory to fill the boxes. And unfortunately, that means all of this that I put on, I need to clean it off. This is, again, when we're dealing on a $400 case from a name brand manufacturer like Cooler Master, you should not experience old thermal compound with poor viscosity. It's really dried out. And spreading that is hard work. The more I move it around, it shifts. It actually wipes the CPU clean as I push the thermal compound down, and then it covers up another area of the CPU's heat spreader, but in the process, completely wipes it. It shouldn't be so dry that it drags. It should be like paint. It should go on just like a thick paint. Can you imagine trying to paint a wall and the paint is so dry that it's thick, right? And it's leaving globs. And as you try to spread the glob out, it completely disassociates with the wall. And so whatever color you're trying to cover up with the paint It's then back as though there was never any paint. That's how cleanly this is coming off when trying to spread it. That's an indication this is bad thermal compound. Let's not use it. Now, thermal compound is cheap. I always have spares, and you can get like something like Noctua NH1 thermal compound for about $8 a tube, I think, and it'll last you several applications, and it will not come out like this. Now, there's nothing specific about Noctua that I would prefer other than value. Arctic Silver is also good value, and there's a few others out there, and they all pretty much cool exactly the same. Now, what I'm grabbing is a paper towel because I need to wipe this bad thermal compound off so we can reapply cleanly some other thermal compound that I have that I know is good. The good news when you have this problem is it's usually really easy to take it off. It doesn't stick very well to the cooler or to the CPU. It's sticking better to itself. So as you start to remove it, it kind of helps. It helps you by, it's almost like it's magnetically attracted to itself. And it means the cleanup is really super easy because it's not so, it's like picking up a ball of clay versus trying to put some paint back in the can. So for that, that's the good side, but it shouldn't be that difficult. Like I said, we could force it and we could make that work, but I wouldn't, not for as cheap as thermal compound is. And there's no way to know if the thermal compound that was included with your cooler is adequate or, you know, let's say fresh or dried out until you squeeze it out and apply it. So before we replace it, we want to get the surface of the CPU clean again. And for that, I use 99% isopropyl alcohol. Rubbing alcohol, they call it. The higher the alcohol content, the better it will evaporate quickly and leave behind very little what's the word? Impurities. And the cleaner we get that, the better our heat transfer will be through the thermal compound. And that's why it's covered, the base is covered, and why the CPU is covered in plastic is to keep that surface clean from any dust, dirt, oils from your fingers, etc. And you can see that comes out pretty filthy. We'll do that one more time just to make sure we get it extra clean. What we don't want to do is we don't want to mix two entirely different thermal compounds together. So if I had a bottle or a tube of Noctua NH1 and the tube ran dry, like I'm starting to apply it and I just didn't have enough, another exact same tube of Noctua NH1 could be blended in. But I wouldn't grab another brand or a different model of thermal compound and blend it together. That's a recipe for disaster. They're not designed to do that. And, well, you might be trying to save a penny. It's not ideal. It's not going to say guaranteed it's not going to work, but it definitely won't be as efficient. All right, let me get these Q-tips out of the way because they're going to stain my desk if I don't. And while I'm walking away from the camera, that gives the alcohol time to evaporate. Give that a minute before we reapply new thermal compound, because you don't want to, I wouldn't dry it off, number one. Let the air, just let it naturally evaporate and wait for that to be dry before you apply your new thermal compound, or you'll be diluting it. And not only that, the thermal compound won't spread right because you've thinned it out with the rubbing alcohol. Hey, Mara, did you have something you wanted to say? Did you have something you wanted to tell me?
Yeah, I was going to tell you can check your email.
Oh, I can check my email now.
Yeah.
I thought maybe that's what you were going to tell me.
Yeah.
All right, well, we'll just give that a minute to dry. And let's take a look at email. Oh yeah, I see I've got a message. Oh, our friend Charlie Purdy sends an Amazon gift card for $100. Again, thank you so much, Charlie. That's very, very generous. Right on. All right. I think I'm ready now. And this time, well, speak of the devil, there's some Noctua NH1 right here. I also have, what is this? Thermal compound. It might be crap. I don't know. And then I have a bunch of these syringes of Scythe thermal compound that came with the Mugen coolers. I installed so many of those. I've had really good luck with this thermal compound. No matter, I mean, I can't tell you how long it's been in my inventory, but very rarely have I ever extracted any from here and found it to be dry. So for that reason and that reason alone, I'm going to stick with past experience here and assume more of the same rather than rolling the dice on those others. So let's try this again. And you should see a difference with how this applies. I'm going to do the exact same thing I did before, which is to draw a big fat line down the middle. And now look, I have run out of what's in that tube. Now, did what I put on, is that going to be enough? If not, I will use some more of the exact same thermal compound. These can be mixed together because they are exactly the same. So that's the only time you can mix thermal compound. But before I do that, let's see if what we've got is enough. Now that is spreading so much easier. If you look at the speed of how quickly I'm able to move this around, it's a little bit, dare I say, slimy. And the other thermal compound that we just tried was more clammy. That would be the best way I could describe that. And then I'm going to tap up and down across the thermal compound, and this creates little hills and valleys. That gives the compound some room to expand when we squish the heat pump on top of it, the cooler plate. And this way, I've ensured I have 100% CPU coverage evenly across the entire surface of the CPU. So now, which one was the empty tube? Well, looking at the plunger, I have to assume that's the empty tube. And this one I'll put back. I guess I didn't need to blend them. I had just enough in there for another application. And that used to be the norm when you bought a cooler, is they would give you enough thermal compound for at least 3 applications. But chips are getting bigger, so bear that in mind. A Threadripper is, massive. It may require 2 tubes of what a cooler manufacturer might include. But if you buy thermal compound, there should be enough in the tube that you buy, like from Amazon or Newegg, that would easily cover a Threadripper. Because that chip's 2.5 times the size. So obviously it requires 2.5 times the amount of thermal compound. Okay, so with the trash out of the way, and that thermal compound, by the way, it gets everywhere. It can get messy and difficult to clean. So I try to get that away from my desk and work area as quickly as possible, because that's quicker and easier than cleaning it up later. Okay, with everything out of the way now, to put the block on, you really should work with gravity. So to do that, I'm going to go ahead and set the case down, and do know that the block is attached here. So don't let that bang around or knock things off your desk. And again, I hate to do it like this because you don't really get to see anything, but let's bring this down here. And we've decided earlier that those hoses are going towards the RAM. And then this piece we're not using, so we're just going to peel that off as though it were like any other cooler that was got a sticker on there protecting it. Now I'm going to set the cooler over the posts that stick up from the bracket we installed. And it should self-align . it's weird because it's rocking back and forth, and I don't understand why it's not sitting completely flat. I have to assume that when we put the screws down, that's going to keep it flat. It's not reassuring. I feel like something's trapped under there, but it just may be the way this is designed, and I'm just not familiar with this installation method. I don't think I've ever used a Cooler Master. Well, that's not true. It's been years, I think, since I've installed a Cooler Master liquid cooler. So now we've got the 4 thumb screws. This bag is empty, we're done with it. 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 Look how clean the counter got. These little thumb screws are just going to sit right on top, and they're what's holding the cooler down and putting pressure onto it to make sure that it's flush, completely flat against the surface of the CPU. And that thermal compound, whether we would have placed it on the cooler or on the CPU, we do one or the other and not both. And as you bring them together, the compound transfers to the similar location above it or below it. So what I do is I start these screws, just get them started. Now, if you've ever heard me tell you to, when you're putting in screws to go opposite corners, it's on the cooler we talk about that. Lately, we've been hearing from some people who have unfortunately over-tightened their coolers. So don't do that, because you can break the screw right off, shear the screw off. So what I'm going to do, now that I've got them all started, don't start one and tighten it too much, because it'll tilt the cooler this way, and then you can't get the screws started without adding a lot of pressure. You don't need to work that hard. Just get a couple of turns on one screw and go to the opposite corner, get a couple of turns on that one, and that way you're not putting so much pressure on one side that you have to counter that pressure with your physical muscles to push down at the same time as putting on a screw. You can, if you want to work that hard. Once we get them started, then just pick a random corner and start to tighten it down a little bit more. And go to the next corner, just tighten that down a little bit more. And go to the opposite side, tighten that one down a little bit more. And finally go to the last corner, which is opposite, and tighten that one down a little bit more. Now, as you start feeling the thumb screw give you some resistance, that's where we go like 1, 2, 3, 4, 5, and then come around the other side and do 1, 2, 3, 4, 5. And we're just trying to go all the way around opposite corners so that there's no warpage occurring. See, now this screw is already tightened way too soon, so I'm going to back it off. In fact, I'd say that screwdriver is not fitting very well. It's sliding around. I'll use the screwdriver Alzai gave us. See if that's a better fit. No, that one's sliding around too. What about the Mugen screwdriver? Don't I have one of those? No. And they don't give us a screwdriver, and those are rather shallow. How about just my standard Phillips number 2? Would that be ideal? So what's happening is the minute the screw hits a stop point, the screwdriver is slipping inside of the head of the screw, and that can cam it out, basically, tear up the threads. So I think the only safe bet for this kind of thumb screw is a straight edge, a flat edge screwdriver, which the Alzai, if you turn it around, it gives you that flat edge, and it looks like that's what Cooler Master wants us to use here. I'm not a fan of screws that use flat edge. Yeah, the grooves in these thumb screws are so shallow, everything I'm using is slipping out. And it doesn't appear that they've given us a tool. Let me just make sure I haven't overlooked anything. That's quite unusual. No, they don't indicate in the pictures any tool being used. It's just screws and where they go and what direction you turn them. How you're turning them, that's on you, I suppose. So I do have my number one. Maybe the number one will fit better. It's still pretty loose, but I think that's as good as I'm going to get for today. And you know what? We don't want to over tighten anyway. And having those cutouts in the top of the screw so shallow almost guarantees you can't over tighten it because your screwdriver is going to slip on you. So I do opposite corners. And at this point, once you've got them down so low, eventually you say, okay, I'm going to turn the screw until it stops and then try and give it a little bit more. But that's it. We're good. Go to the opposite corner. Once again, even after you've already gone around, go around one more time, because sometimes as you tighten up one side, the other side gets loose. So we go around one more time. That one's not even budging, and that one's not budging. That's as far as we take it. Don't try to make it budge. It's telling you, stop. If you force it, you start to bend the motherboard. And then you get weird problems like, how come some of my RAM sockets don't work? I don't know, maybe because you just warp them like that, and when you put a straight stick of RAM in, none of these connections on the edges are being met anymore. Or maybe you crush the circuitry. Multi-layer motherboards these days, they have circuitry that could be 7 layers deep. And you can only see the top layer and the bottom layer. And when you squish it down, you might squish the layers together and break the connections or short them out. So we want it tight, but don't over tighten. Okay. It's coming to my realization that following the pictures in the documentation that the hoses are towards the RAM, the Cooler Master logo is sideways and the Atmos is right side up. I, for some reason, pictured it in my head that this was rotated 90 degrees with the hoses coming out towards the RAM and the Cooler Master logo being straight. So if you look at the top of the case, like for example, right up here, you see the direction of that Cooler Master logo. Or if you look up here on the very, the front of the case, let's go to the front. Hold on a second. I had this on its back. Is it right now? Oh, okay. I forgot. I wasn't on the feet. All right. Yes. Perspective changes, right? So with it on its feet, now the logo is correct and the RAM is that direction. This makes much more sense. I've just confused myself unnecessarily. Par for the course. These videos are live, and perspective is very important. So there you go. There's the logo, the correct orientation as I thought it would be, and then the Atmos is written sideways there on the side. All right. Phew. Now, when it comes to hooking these cables up, we have the water block where the pump runs full speed all the time. And the way you accomplish that is your motherboard may have, right up here by the CPU header, it may have a header that says AIO or WB for water block. And what that means is there's no fan control. It runs full speed at all times. You wouldn't want your fans running full speed at all times. It's noisy and draws a bunch of dust into the machine, dirt. But on a water block, regardless of the CPU is cool or hot, the water block always runs full speed, and then the fans on the radiator are what speed up and slow down depending on how hot the CPU is getting. That's how that works. If you don't have an all-in-one header, or you just don't want to use it, you can still plug into the CPU header, go into the BIOS, and there'll be an adjustment to say, this is not a fan, this is a water pump. And the way that, the reason why that's there is so you can tell the BIOS, don't adjust the voltage, keep it straight voltage the whole time. Now on this motherboard and on most modern motherboards, you're going to see an all-in-one header. So let me grab my flashlight. And again, you can look in your manual, but it should be etched on the circuit board. Yeah, so here we have this black fan header and a white one. And the white one just below, it says AIO pump. So we take the fan header here and plug it into the white. On this motherboard, it's white. They're not always in agreement. There's a better way to show this to you. And then the other cable we've got, this is our ARGB. This is going to control and synchronize the lighting to match the fans on both the cooler and the rear case. And the motherboard has some RGB on it too. And if we want to control all that with one piece of software and have it all synchronized, then we can either download a third-party utility or preferably just use what the motherboard manufacturer includes on their website, where you need to go and download that MSI Mystic Light for MSI motherboards. ASRock has something called Polychrome Sync. Asus has something called Aura. Once again, they sue each other, so this is why they have to come up with their own software to do this, but it all meets the agreed upon standard of addressable RGB. So long as the RGB you're adding is addressable RGB, there's no incompatibility between manufacturers. Now, when it comes to putting the addressable RGB on, we can either wire the block right onto the motherboard. We have two ARGB headers on this motherboard, which is a nice touch because some motherboards only give you one. And I have two right up here, right next to each other. I also have one maybe down here. Yeah, so I have three on it. That's pretty nice. This is also a $350 board. The more you spend, likely the more little headers you get for fans and RGB. On the other hand, with ARGB, you can string them all together, just like Christmas lights, which would mean I would run that cable to the back to the fan controller and run the fan controller onto the motherboard. That would work exactly the same. So this is about what's going to look best. And in either case, I have to run this out some way. So does it make sense for me to run it up here? Or does it make sense perhaps for me to run it down through here and kind of hide the cable in this little crevice and then plug that in to our fan controller. So you see all these ARGB. I'm looking to see if there's a blank one. There's a blank one right up here. Or I can, again, I can string them together. So I could just grab literally any of them and take these two and just push them together. And I will accomplish the exact same thing. This is just a little dust cover, and it's there to prevent the pins from getting damaged by being exposed. You may choose to leave those on or take them off. I usually leave them on until I need them, just for the reason they're there, is to keep any damage from occurring to those pins, because they don't have a housing around them. They're just exposed, and you wouldn't want those to hit the metal and ground out either, because it could short circuit metal on metal, the ARGB voltage and communications that's controlling the colors. So that accomplishes the water block. Then finally we have, our front port headers, and we have USB 3 right here. And I do like that they place these holes very close to where we need them to go. In fact, we go in that top one, and you can see that that takes us pretty much right to where we need to plug in on this motherboard. Some motherboards are going to have an adjustment on where that USB 3 header is, but they're usually within a couple of inches of each other. And this one just happens to line up. Now this connector is purple, and you'd think that motherboard manufacturers would make the USB, the surround around it, purple, and you'd connect purple to purple. Wouldn't it be great? So Cooler Master has done that, and kudos to Cooler Master, but ASRock has not. So again, they're not in agreement on the standard. They're not the same company. They don't work together. So if Cooler Master says this is purple and this is what the USB 3 header should be, that's probably under advisement from the USB 3 committee that decides the standards, but apparently they're optional. Regardless, that's the only place the plug will fit, so I don't know how important color coding is, but it is what it is. Now again, we are not going to be using the ATX 3.0. We're not putting an external graphics card in this today. This is our USB Type-C, and that's going to plug in pretty much usually right next to the USB 3. It's above it. So we're going to go into the same hole with our USB 3, and we're just going to plug that in right above it, and that should just snap right in there. Now, our motherboard power cable, and this is what makes this case different. Motherboard power is here. And so normally you'd fish through your power supply power cable through one of the holes and plug it in. What Cooler Master's done, which is actually pretty clever, is they've given us the power supply pre-installed into a connector that you can remove if you want to. And you plug this little patch cable, if you will, into the back of the motherboard tray that the power supply is plugged into from the factory. And just take this and bend it around and plug it right on to your motherboard power. And what this does for you, not only are the parts pre-installed, but you don't have any cable management to deal with now. It's taken care of for you. So if you're somebody that's intimidated by cable management, having a case that's pre-installed with the cooler, the power supply, and these little power connection blocks is pretty handy. Even if you wanted to add a graphics card, instead of coming through a hole on the power supply shroud, they've given us an 8-pin PCIe graphics power connector right here that you would just run to your video card. Unless your video card required the ATX 3.0, which is the cable I showed you earlier, or if you required, like this will split off to 2, but if your video card required 3, you'd still have to run a separate cable. So this is only going to fit some video cards, but again, it cleans that cable management up for the vast majority of the mid-tier graphics cards. It's only the really expensive ones that require the fancier or more of these cables. Now, these are two CPU headers, or not headers, these are EPS power connectors that are going to connect the same way. So up here at the top, Cooler Master has pre-installed 2 plugs that these little patch cables go onto to support up to 2 on your motherboard. This motherboard does have 2. So again, we can go and plug in the little patch cable on number 1, and we can plug in the patch cable on number 2. Now pay attention, because one end of this splits in half. That's the end that's supposed to go to the motherboard. So it says CPU on the end that goes to the motherboard, and this end says nothing at all. So it looks like I got that right. Just looking now. Did I plug in the right connector? Let me take that back off and just double check my work. Yeah, that's a solid connector. This is also a solid connector. So these two connectors are slightly different. This one splits into an optional 2 4-pin connectors. So if your motherboard takes an 8 and a 4, this will accommodate. If it's a single 8 or a single 4, this will accommodate. Or if it's 2 8s, this will accommodate. See what I did there? Accommodate 8. Comma 8. Okay, and it doesn't matter which one goes where. Ultimately, it's what looks best. We don't necessarily want to entangle them or, you know, for the sake of keeping it consistent, because one end says CPU and the end that says CPU here is split, we'll keep them both the same. And I'm going to just plug both of these cables in again to the back of the motherboard tray. So you see they're right here. And then probably take the one, I don't know, I guess it depends the way you want to look at it. You can either run the one that's closest to the closest connector, but that means the one that's furthest has to wrap around it, or take the one that's furthest and put it to the connector that's it's closest to. So my instinct is, in either way, it works, by the way. My instinct would be, let's take the furthest connector, plug it onto the closest one, and then take the closest one next and plug it on to the next one over. But I could do the opposite. I could take these two and keep them really close together and then have this overlap both of those. It's an aesthetic choice. one way or another, one is overlapping the other. So I think just personal preference is going to win out in this. But for the sake of not stretching this, pulling this cable any tighter to get it to reach the far end, that's what I'm concerned about mostly. And working on this upright is a little bit difficult because the cables don't give you a lot of slack. So I'm going to just set this on its side again. Oh no, my Corsair logo went sideways. All right, and now this is a lot easier because I can see from the overhead light the black plug and the black connector. And it doesn't matter which cable goes where. If the plug fits, it's the right plug for that cable. Now, we probably only need one of these 8-pin connectors on this board, unless we're overclocking it. But you know what? It doesn't hurt to have it. Even if you don't need it, since the power supply that the case comes with already accommodates, let's use it. Well, at least let's plug it in, even if we're not actually using it. So what's left? We have front port audio. And what are these? Oh, fan headers. So this will be the power that goes to the fan controller that has a fan splitter already built into it. And this is our master ARGB that also goes to the fan controller. We have to plug this into the motherboard. How am I going to do that? Where should I plug this in? I want to keep it as hidden as possible. My guess will be right down here. We can run this cable right up through the bottom. All of the ARGB headers on this board are all paired together, so it doesn't matter which one you use. Some motherboards only give you one. Some motherboards give you none. So that's our ARGB plugged into the fan controller, and then the fan controller splits that out all by itself. That takes care of that cable. Now, fan power to spin the fans, that needs to plug into a fan header. And again, that's going to go into the fan controller that divides the power and splits it to all the fans. That keeps them all running the same speed, so the top fan won't run any faster than the middle or bottom, because then it's going to look weird. So for that, we can use, where's a fan header on this? That's hidden. What do we have? I have 4 fan headers right across the bottom. This motherboard is extremely well equipped, I must say. I understand now why it was $350. We have a lot of options that are not standard on cheaper motherboards, even if it does have that 10th mounting hole, for no good reason. These are extra power cables off the power supply, which I think we have a choice of unplugging these and putting them in the box, or just grab a nylon zip tie if you don't want to go hunting for where these are later. For right now, I think I'm just gonna shove them inside and clean it up later, but because they're dragging across the desk, they got caught in the drawer earlier when you saw me trying to spin this, and it wouldn't spin because these cables got caught into this drawer, and when I closed the drawer, Murphy's Law, you know, they go right in there like Romeo and Juliet. All right, I'll try and keep those two separated, I'll tell you what. All right, get this tied up so that won't get trapped in my drawer anymore. One. Now again, I won't close and button up this case with any wire ties in it. Those will be replaced with nylon zip ties unless I decide to just unplug these cables from the back of the power supply and put them in the box. Either way, I don't think there's a wrong answer. It's a personal preference. Because of the power supply shroud, you'll never know the difference one way or the other. The trouble comes when time passes and people don't know where the box is, and now they're trying to add something to the case and they can't find their power cables. And if you look at the history of tech news regarding third-party power cables, say that 10 times fast, causing system failures like critical and totally catastrophic system failures, you pretty much want to stay away from third-party cables, in my opinion. Unless you really know what you're doing and you're paying attention to all the details, it's a great way to ruin all of your equipment just because you lost a cable. Or just be doubly sure you're buying the authentic cable from the manufacturer versus the pretty cable from Cable Mods or something, which potentially could cause harm if you don't pick the exact right cable. You're going to find out if it's wrong in the worst way possible. There are three cables left. We have our front port header, which is power switch, reset switch, which in this case is not a reset switch. So it's hard drive LED, power switch, and power LED. This is front port audio. This is so the jack on the front will work with a microphone, a headphones, or a headset. That's both. This cable traditionally has to be routed at the bottom lower left corner of most micro ATX and ATX boards. So let's just route that. And look how clean the cable management on this, because so much of the work was already done for us. One of the easiest for cable management that I've seen. So this plug right here is going to go, again, I need a flashlight to see where the missing pin is. The top row has the missing pin. So we'll just run that through and make sure that I have oriented that with the missing pin towards the top. And it just kind of wiggles and pushes until it flats out against the socket of the board there. And that's just a gravity tension friction fit. There's no clip and there's no click. You just have to eyeball it and make sure you get both rows of pins. It's possible to only put on half of it and not even notice you did it. So pay attention to that as you're doing it. And we also have a SATA power cable. That is probably, if I had to guess, that's probably controlling our fan controller. The reason I say that is when you split a fan, when you use a fan splitter and you split the power, you're drawing more amperage from that little tiny connector on the motherboard than it was designed for. And this can create bizarre problems. If you can provide power from the power supply to the fan controller, and the fan controller is plugged into a fan header strictly for the purpose of knowing how fast does the motherboard want me to spin the fans based on the fan curve in the BIOS, which is based on the temperatures that you're telling it to monitor, usually the CPU temperature. And say the CPU temp gets really, really hot, it needs all the fans all running at full speed through one connector that was engineered to run one fan. Getting away with two fans on it's pretty safe, but the minute you go 3, 4, or 5, it might be okay, but you're drawing a lot more current. So the fan controller can intelligently power the fans through the power supply's power, which is far more power than that little connector, but use that little connector just for signal. Do we want to run the fans faster or slower? And that's why it connects onto the board, not to power the fans, but to understand the communication of how fast do you want these fans running. And in that way, you can add a lot more fans and your RGB lighting through this power connector. Now, I'm not certain that the RGB lighting really needs any boost in power, but the fans certainly, this is a much safer way to do it. So for those cables I just wrapped up, it turns out I do need one of them. And those will just plug in together right there. Again, this is our ATX 3.0 connector for a high-end graphics card, which I'll just stick in there for now, sight unseen. And then the last connector is power switch, power LED, and hard drive LED. That's going to go up through here somewhere and to the bottom right. And there's no hole here on this side. So that means I need to come up over on this edge and drag it across, or come over to this other hole and bring it the other way. I do wish there was a hole there, but it is what it is. Not the end of the world. I think I want to go this way with it though. go right up through here. So close, Carey. There it is. And then this goes on this final set of pins on your bottom right. They're always in the same order. Hard drive LED on the bottom row of pins with the power connector, the plus sign, closest to the edge, the last pin on the bottom row. Power LED goes directly above that, positive wire above the positive wire below it on the top row. And then the power switch goes beside that on the top row. And they've pretty much been the same for a long time, and I've got other close-up videos that demonstrate this for those of you that are new or haven't seen those videos before. And by now, there's so many content creators out there with some great close-up shots of this regular and routine placement of these cables. It really does not vary from motherboard to motherboard, unless it's like an HP or a Dell. If it's something you're building yourself, the only exception would be if it's a mini ITX build. And even then, the cables usually go on the same orientation, but the cable may be, the header may be sideways and located closer to the power because you're dealing with such a small motherboard. But once you realize which side is the end, right on this side, when the connector's horizontal, it's the far left side when you're looking straight at it. And if it were vertical, it could be the top or the bottom, depending on the manufacturer. You know, they could rotate it depending on how they determine what they want to do. But unless it's mini ITX, it should always be the same order of the cables. So power LED above the hard drive LED with the positive cable at the end of the connector, the far end, with the power LED and switch on the top row and the hard drive LED and reset switch on the bottom row. And that's it. All done. Now, for the very first time, we can turn this on and see if we let out the magic smoke. These little combs, this is what I was telling you about. You can place your hoses from your water block to have that. I mean, it really spreads them out. It's not, I don't know if that's making it better. I almost prefer they were close together, right? Right up against each other. But if you find that more aesthetically pleasing, that's what those are used for. Okay. Now, in fact, if you wanted to, you could turn these, or if you don't want to see the band, I guess you're going to see it either. Well, no. Whatever way you prefer. Okay, let's grab power. Switch is off on the power supply. We'll plug that in. I need a keyboard and a mouse. So here's my wireless keyboard and mouse right here. We'll turn these on. I always turn them off to save batteries. Here's my dongle. I'm going to plug into any USB port back here. I do see some black USB ports that usually indicates USB 2. And it's not like I'm going to type any faster if I plug it into USB 3. So I will save my USB 3s for like more important stuff, like USB drives and external drives, stuff where the performance makes a difference. Our antennas are pre-installed on the board here on the I/O Shield. This does have built-in Wi-Fi, again at that price point. And let's see, we've already installed Windows, so we can plug our internet into that. So down below me, I have, probably stepping on it, our Ethernet cable right here, and HDMI, since we're using onboard video, we'll plug it in right there. We turn the power supply on, now that everything's plugged in, and then we'll locate our power switch right here. That power switch should light up, the fan should light up, the block should light up, and the rear fan should light up. The RAM is RGB, and that has lit up. And if we go to this output to see what's happening, we can tell the capture card now, show us what's coming out of this cable now. And right now it says, I got nothing. Oh wait, yeah, there it goes. So now there's our post screen for the Phantom Gaming on our boot up. Because we already prepped the motherboard with Windows 11, this should boot us right into Windows 11. And because there was an update the second Tuesday of the month, which was just 3 days ago, I'm sure that update is still waiting for us to apply. So let's go over here to full screen source. There, now I can see. Let's go to Start, Settings. Windows Update. Check for updates. Now, to me, the fan is running a little bit loud, but I can adjust that in the BIOS now because the fan controller is hooked to the motherboard, and the motherboard is giving the instruction based on the BIOS settings, which right now are a default. It's not that it's loud, it's just more noticeable than I thought it would be. I thought it would be completely silent. But there's definitely the slight hum of a fan, which is not terrible, but we can probably improve on that. When these updates install, the next thing we can do is check to see if our cooler is running well. This is a 125 watt CPU, the Ultra 7 265K. And if we run Cinebench on it, that will torture it. And let's see how well the cooler does for keeping this chip cool. Well, that is updating. Let me get out of that screen. Maybe. There we go. And let me take a look at what you guys are saying in the chat room, because I've not been looking. Paul1961 said he didn't get a notice of a live show. Well, pretty much every Friday at 1 o'clock would be a good time to check in. 1 o'clock Phoenix time. And while I wasn't certain we were able to start on time today, we did, and it was my goal. And I met my goal. Normally, that is standard and should be expected Fridays at 1 o'clock Phoenix time. Just an FYI. Just looking through your chats here as we're waiting for updates. Sure, I'm missing anything, but if you did ask a question and I hadn't seen it, please repost that into the chat room. Now, while we're waiting on this to install, and in case you're curious, essentially the cable management we have to do is quite minimal because everything was mostly done for us. I mean, I do have a little bit of a cable here that I can wrap up a bit. There's not much I can do more with these hoses. These cables are already pushed in about as far as they can go on the bottom here. So just to see what it'll look like when it's done, we can take an early peek by putting this panel back on, because this goes on super easy. Just slide that into the, it's like a big lip that it hangs on, right? And it just kind of hangs open. And then it's got two metal nubs that stick out and get seated in. And then there's a thumb screw, which I left here on the desk, that goes in here. And that's what you can expect your completed build to look like using that included liquid cooler. With one exception, obviously you would want to peel the plastic because the glass will be a lot clearer if you do. And let's see how our BIOS, or not our BIOS, let's see how our Windows updates are doing. Still installing. Johnny says, what happens to the post beep? Well, back when computers, home computers, like the IBM personal computer back in 1981, when they built those, they used to put a little speaker inside of the case. And that speaker would give you the beeps, and we didn't have sound cards back then. They were very limited to your sound quality. And over time, that speaker has been phased out. Cases no longer come with speakers on them anymore. And customers have said that that beep is annoying and we don't want it. So while the motherboard still has a place on it, most motherboards do, to plug in a speaker, most people find that annoying because it's not coming from the sound card, but rather coming from a 2-inch, really poor quality speaker that is very limited in its frequencies that it can play out. It's got no bass. It's just a terrible old 1980s speaker. These days they have little piezo speakers that plug in and hang off the motherboard. If you want to add that, they sell them on Amazon. And sometimes you might get a motherboard that includes one, but more and more people don't want them. But that was phased out somewhere in the late 90s. That was phased out. And cases no longer come with the speakers built in. But if you look at some YouTube videos where they're demonstrating an old AT style, 286, 386, or 486 PC, you'll see a speaker built into the case, and it's exposed. It's not enclosed. It's just right there out in the open inside of the case that will not have a case window, so no one would see it. But yeah, when you take the cover off, you'll see it there. Today, I have not seen a speaker included built onto the side of a case in 25 years. But again, you can still add a little tiny one and hang it off the motherboard if you want to. Nick Caffrey says that is a stunning looking case. You think so, Nick? Hey, Mara. Let's see what Mara has to say. Will she be impressed? Tell me what you think of the looks of this case.
So I like it. I mean, it's nice. I really like the way it looks on the inside. I like the way it looks on the inside. It's nice.
Nice enough to make it yours?
Nice enough to make. I want to say yes.
Really?
Well, not only is it obviously it's built by the best, it also the bundle that it came with I thought was. I have not seen anybody else before.
Well, Cooler Master did it on the Encore build. Yeah.
Okay, so
same case maker.
But this has the custom AIO, and it's got.
So did the Encore, but it was for mini ITX only.
Right. So, which I'm not a big fan. So this is better. But I love the bundle. I do like the way it looks. It's nice. If it was a full size case, like the
that's
Apache,
not a full size case. Oh.
Like the Apache.
It's not big and heavy enough for you?
No.
Of course not.
So that's if I was going to knit thing, that would be my only desire. Would be, this case. That's mid ATX.
Now you can see all the fan and RGB is all synchronized together.
Yeah.
But we can control that with by downloading ASRock's polychrome sync software.
Really
we can
nice.
change the patterns or pulsing or whatever it offers.
Yeah, really, that's a really nice.
It should perform fantastic.
Oh,
I mean, the Ultra 7 is nothing to turn your nose up at, especially for the price. Right. The Ultra 9 is like $200 more and only performs like 10% better. It's definitely not for anybody who is good at math, but the motherboard, I also think, with all of the fan headers and ARGB headers, I like that. The 10th mounting hole, I didn't like. That's my one complaint.
Right.
The NVMe drives install very easily, and the board is this unique purple look, which you can't really see, but that reflection of what's going on that big heatsink, you can kind of see it right there. It kind of looks like it moves just by the light hitting it. Oh, I see it just fine in the camera. But again, if it's down on the floor, and especially if this is like if the computer's on your left, this will face the wall. No one can see it. Right. So you would miss out any opportunity for the advantage of that. But that's true of any glass case that it sort of presumes this is going to be on the desk, or it presumes the computer will be on your right, because this side is solid.
Well, that's why the attachment.
Yeah, but you keep the computer on your right.
I do.
Mm-hmm.
So like,
all right. Well, it's interesting to know your thoughts.
I really like it. I like the case before it was ever built. I mean, I like the. It's like it's enough uniqueness that I mean would be
Unique enough. I like that the cable management is going to be real easy on this because it's mostly already done.
Yeah.
I'm going to replace wire ties with nylon zip ties and pretty much 1 or 2 cables and I'm done. Then the back panel goes on and I don't know, maybe we'll find a use for it or maybe someone will buy it. I don't know, but it's definitely, I think, a good value for what you're getting. It's not cheap, but it's also not too expensive.
Right.
I think the performance is going to be outstanding. And we'll just have to wait when these updates are done to run Cinebench to see how well this cooler works with that CPU.
Yeah.
And we're about to find that out here next. All right, well, let me just take a look here in the chat room. See what you guys are talking about. Of course, we appreciate your thoughts in the chat as well. Martin Hogg said, Carey is a lovely build. Did you get my small gift okay? You know, I haven't checked the phone. Let me check, Martin. Good to see you here in the chat. Martin joins us from Scotland, I believe, right, Martin? It appears a gift was sent from Amazon. Is that right? It says the gift is hidden for privacy. I have no idea if that's what you're referring to, Martin. I've never seen Amazon offer that before. But if that is you, thank you for whatever it is. And I guess we'll figure it out when it gets here, huh? Usually when people send gifts, they don't want you to know the price. This tells you the price, but it doesn't tell you what it is. That's different. But thank you, Martin. If that is from you, which is, I'm guessing. Robert Jones says hello. Stephen Kelly says Scotland here too. Hey, that's pretty neat. There's a lot of people from Scotland in our chat room. Have they come out with 15th gen CPUs yet? That's what's in today's build. The 15th gen is called Intel Ultra. So there's the Intel Ultra 5, the Intel Ultra 7, and the Intel Ultra 9. And those are all your 15th gen. Marketing at Intel has decided to change the naming convention, and AMD has responded in kind, and they're changing their name as well. So more of the same, right? When we went from 286 to 386 to 486 to Pentium, right? We got rid of the numbers, and then Pentium 3, Pentium 4, and then we went after that to Core 2 Duo, Core Duo, I think Core Duo, and then Core 2 Duo, and then we went to this i3, i5, i7, then added the i9 later. We also had Celeron, dropped the Celeron, changed that to the letter N. So like N100, N95, that's Celeron. And now the 15th gen is called Intel Ultra 7, Ultra 5, Ultra 9. And then within those categories, there are different models, but right now only one model of each because the chip is brand new. And in the coming months ahead, we should start seeing a number of different i5s that are ultras, i7s and i9s. Right now there's only one of each, just the pinnacle of each one, and then more budget options will be introduced probably any day now, right? Because we're already quickly nearing the end of the first quarter of the year. So I suspect we might see it in that first quarter, but I don't know what Intel's release plans are. But those were released back in November. So was it November or was it I think we got the CPUs before we got the motherboards, if I'm not mistaken. Mark Gaines with a 10-pound super chat said, here's a nice case. I also sent a little something via PayPal. Well, thank you, Mark. Again, sometimes those PayPal contributions are... Let me get out of that. Come back over here. As I was talking to you, all the lights in the room went out and came back on again. We are having some weather outside, and it might be related to that. So it's what we call a brownout. And obviously, if we were on a UPS system, it would have kicked in and prevented that from happening. But this almost never happens. And the maintenance of a UPS and the cost of a UPS would be worth it if it was a more frequent thing. That's the first time I've experienced that, and it could be for a number of reasons that the power company had switched something over or something happened that resulted in that minor brownout. And when the brownout occurred, the computer stayed on, but the modem disconnected and had to renegotiate back to our provider. And then that takes a couple minutes, and then that reconnected, of course, with our Wi-Fi router. So the whole time the computers were on, they weren't shut off or affected by it, but the lights absolutely got dark in here and then came right back up again. So again, we call that a brownout, and that's what can really damage your equipment, that kind of thing. If it happens frequently, anything that's turned on is basically losing power and getting it spiked right back. Now, today's modern power supplies handle that pretty well, but lights are going to really show what's happening because they're dim. They're going to grow dim and bright again. They don't have any sort of capacitor to carry them over the way a power supply might. But again, that was weird, and nothing on your side was the problem. We experienced that here. It's very strange, very uncommon. So just real quick, let's go ahead and run Cinebench on this. Hopefully this has rebooted. We did have another disconnection. Usually when brownouts happen, my advice for people is to unplug equipment until you're certain the brownouts have gone away. This would be like during a storm. Wait till the storm's over. In our case, we're not necessarily having a storm. We're getting some wind, but whatever caused the brownout is still having a little bit of difficulty getting back on its feet. And as a result, it dropped us one more time, but that time was just for a few seconds. So hopefully everything's good again. So what I want to do is go back over to this desktop, and I want to run Cinebench on it, because the show must go on. And let's take a look at HW info. Let's see where our temps are right now. And again, I'm leaving the fan profiles at default. I think I'm going to quiet it down a little bit, but let's just see where we're at first before making any adjustments. You know, we're going to try the food before we add any salt or ketchup. Try it first. So right now we're sitting really good in the 30 degrees Celsius range currently. And you know, you see you got 20 cores on this CPU, this Ultra 7. Let's go to Cinebench and get that started right here and right here. And let's start this test. And while that's running, I'm going to close this window. I don't need it open anymore. And we'll bring up our hardware info so we can watch the temps climb, because the first 90 seconds of each of these two tests are pretty extreme on the CPU. And right now, this is our current temp in this row, the third row over here. This is the one we want to watch. This is recording the maximum temperature recorded since we started the software for each of these cores. And right now we're sitting really nice. We're at 9 minutes and 27 seconds, so just a little over 30 seconds into the test. And again, the first 90 seconds is likely going to show us peak scores, and then for the remainder of the test it likely won't exceed that. And then we'll do the single core test afterwards and see if it gives us any new peaks. But 82, I see 82 down here is a maximum. and that's well below where, again, I get a little bit worried around 85. I do see a core temperature at 88 there. That makes me a little bit nervous. But again, these are momentary. We're not at 88 right now. It just kind of, this number here is where we're at right now. And then it reaches up. It's hit 90 on the core. And I think that's on the core package, if I'm not mistaken. And then these are the individual cores. So that one right there is hit 88. That's core 9. We often see peak temperatures for whatever reason on cores 9. This is always a performance core that's going to run hot. Performance core 18 is recording at 92. And again, we're now getting close to 2 minutes of the test, and it's still getting hotter. I see 94 being recorded. Right now it's at 90. Now it's at 88, but the highest it reached was 94. And that temperature, the max temperature, is represented up here at the top, so you don't have to look through all these numbers. Sometimes individual cores will run slightly hotter or cooler than those around it. That's sort of the nature of silicon. And, you know, 94 is worrisome, quite honestly. I'm not real comfortable with that. 96, even more uncomfortable. And usually we don't see any more high temperatures from this point forward on the rest of this test. So I'm getting some results that I'm not real pleased with. 98. Now this chip will start to throttle at 100, I believe. But what's interesting is if you look at all the neighboring cores, the max on 0 and 1 has been 78, which is fantastic. You know, 88 on core number 6. Ooh, 102. At this point, I stopped the test. I don't want that. Even though it's going to self-protect and start throttling, I absolutely don't want to heat up that CPU to that extent. So a couple of things may be happening here. One, I may not have that cooler installed completely square on, right? Because it's a new cooler for me, and it might be in my best interest to take that cooler off and reinstall it again, just to verify that I get the same results. Because if it's on the builder, it's an easy fix. Just take it off, put it back on again. We can also inspect the bottom of the cooler and make sure when we look at the bottom of the cooler that the thermal compound is covering exactly what's underneath of it. Remember, we covered the CPU. So when we put the cooler on, if the cooler is flat and making full contact, then when we take the cooler off and look at the bottom of it, I don't want to see just half of my thermal compound. That'll tell me it's on side, you know, it's got a little crooked to it. So that's first indicator. The second thing would not be the thermal compound unless you put on too little, right? The quality of thermal compound doesn't really make much difference. Where it helps is over time and how that thermal compound dries out. More expensive thermal compound doesn't dry out as fast, or at least that's the sales pitch. So if you're somebody who's constantly taking your heatsink off, or somebody who replaces your thermal compound every couple of years, don't waste your money on the expensive stuff, because that's meant to be one and done, or it's meant for extreme overclockers, using liquid nitrogen and things to cool, or, you know, having some extreme setup that would require extreme coolers, extreme compounds, and extreme overclocking on extreme chips with extreme budgets to match using extreme power supplies. So that wouldn't be the problem. This cooler should be able to adequately cool this chip. So I'm leaning on a couple of different things. One is I never heard these fans speed up at all. So during this whole process, this fan stayed at a consistent sound. I need to go into the BIOS and make sure that the fan is hooked up, the fan controller is hooked up properly, because the fan controller should be getting instruction from the motherboard to speed up those fans. And that may be why it's overheating. Now that I'm saying it out loud, I'm realizing I never heard the fans get loud. They are not ramping up. That could mean that I've got the header not plugged in straight. Sometimes people can be off a pin and not realize it. And that's a very easy thing to look at. In fact, there's another thing I can do. And that is, instead of plugging onto a chassis fan header, plug onto the CPU fan header that we're not using because we're using the all-in-one water block header. So while I did indicate earlier I thought the fans were a little bit loud at idle, they never got louder. In fact, they seem to be running at one speed. So that indicates to me that the motherboard is not sending the signal down here where we plug the fans. But it would definitely do it up here at the CPU. So if I unplug, is it this one? It's got to be this one. Unplug that, and normally you hear the fans now. So that's likely just a BIOS setting, but just for clarity, if I plug this into the CPU fan header, that should be controlled by the temperature of the CPU. Instead of having to manually adjust the BIOS, those BIOS defaults should be such that it'll send a signal to that fan header based on how hot the CPU is, in theory. Now, when we go into the BIOS, we can see the RPMs reported on each fan header. That's almost universal. And we can adjust the fan curve to where we want it to be. And these fans, since I unplugged them, they just got really loud. And when I plugged them back into the CPU fan header, they've not quieted down at all. So this is something you should be doing with the computer off. So what I'm going to do is we're going to go back over here to camera 2. And I will imagine that those fans running that fast and loud are probably keeping our temps even cooler. So if we look on the screen, forget the right side because we're not, those are the peaks. Where we're at right now, we're in the low 30s. But the fans are running much faster than they should be. This is how fast they should have been running over here when we were reaching those higher temps. So let's shut it down, shut her down. Let's go into our BIOS. And I don't know if the brownout also had any effect. So what I'm going to do right now, anytime you get a brownout, there could be these weird after effects, right? Where the board just, you ever see somebody, they're starting to fall, but they haven't quite fallen and they're still kind of moving kind of wonky, and they're either going to get their balance or they're still going to fall. Sometimes after a brownout, the computer's trying to stay up on its feet, but it may be a little wobbly and you might get some weird behavior. And the best way to deal with that when it happens is to physically unplug it. Make sure you hit the power button a couple times to drain out any power. Make sure all the fans have stopped, all the LEDs have gone out, and give it a good 30 seconds to a minute. That should clear out anything that is any remnant of corruption that would have occurred as a brownout, potentially. Right? It's a very simple and inexpensive, do-it-yourself first attempt to repair. Have you tried turning it off and on again? Well, there's a reason why that expression is there. Let's turn this back on, and now let's go into the BIOS. Let's take a look at the way those fans are set up, because so far the fans are... Actually, I'm not going to do anything. Fans are quiet now. Let's go back over to the desktop. Again, let's leave it at defaults. Hopefully we'll get a power on. Yeah, there it is. The fans don't sound any quieter than the other fan header, but I'm curious if they will get louder when we run Cinebench again. Then I'll determine if I need to go in the BIOS. So we're going to come over here to hardware info. And here we go. We'll click start and close that out. Okay, temps again are all reset now. So this is the highest temp we've recorded since we restarted. Let's run Cinebench again, and we should see the results pretty quickly. Now I know what to expect. And now we have something to compare it against. Let's run back over to hardware info. Fans are getting louder now. That's what they should have been doing. That's better. And we're going to keep an eye on this row right over here. And let's see if this makes any difference. Fans are now quieting down. You'll notice our current temps on this first row coincide with how loud our fans get. And that's how it's supposed to work. When the fans need to cool more, they crank up and get louder. And when the fans don't need to cool more, they slow down and get quieter. And depending on what you're doing with your computer and what sort of resource-intensive task you're running, depending on what that task is, if you have fans running at full speed all the time, it sounds like you either have a cooler that's inadequate or installed improperly, that you don't have the BIOS or the fans hooked up correctly, or you've underpurchased a computer for whatever you're using it for. If that's normal in your life, then you underpurchased. In other words, that computer does not provide you with enough power that you're using it for under intense resource usage that's causing those fans to run loud at all times. What we're doing here is running an extreme resource test, which is not typical of an end user, but we want to throw an extreme test on it to see if a user were to run anything extreme on this, would it overheat? And the reason we run the test is to make sure that it's doing what it's supposed to do, which it wasn't doing before, right? It was the fans weren't getting any louder and it wasn't cooling to its best ability, because we are now in 2 minutes into this test, and look at the differences, especially on core, what was it, core 9 was our hot one, and core 9 will still be hotter than everybody else. And we did hit 102 on one of the cores. I can't remember which one, but if you can roll back the video or you remember which one it is, compare it to where it's running now and look at the clock, right? If we look at where we're at now, or this row here is where we're at now. These are our max temps recorded where we are now. And this is how much time is ticked away from 10 minutes, how much is remaining. I don't think we made it this far before. That little tweak of simply moving the fan to the CPU header or going into the BIOS and changing the default. Now you might wonder, why wouldn't you just go into the BIOS and change the default? Because if the BIOS gets corrupted or reset or updated where the BIOS goes back to default values, and this computer is in the hands of a customer, I'm going to get a support call, aren't I? I want everything to run at default as much as possible and to make as few customizations unless necessary, so that anytime a customer does something like the battery dies on the board and it's been unplugged for a while, that when they go to plug it in, I don't get that support call. So I want to keep it at defaults. Customizations are great for you at home. Customizations are a nightmare if you're an IT support technician. And people who work for a corporation who do customizations on their desktop may be chastised by their department leads, because that is a nightmare for the IT department. And oftentimes those personalizations are not allowed at work because it makes the job harder for those supporting you. If you support yourself and you want to throw a bunch of randomness on your computer, knock yourself out. But you'll understand that people's personal preferences can overcomplicate and make very difficult tasks from an IT department, which isn't necessarily trained to handle the individual employee's preferences. It is a workstation and it belongs to the company. It is not the employees. So it's very much an act of entitlement and disrespect when an employee treats it like it belongs to them and has no consideration for the IT department responsible for maintaining that computer. All they're doing, if an employee acts this way, is they're only thinking of themselves. And for very large corporations, those customizations simply are locked out in a group policy. And for other corporations, employees are warned not to do that. Once the IT department deals with it the first time, then the IT department takes it to their boss, then their boss takes it to that department's boss in some kind of a meeting, or it's written down and it's documented, and it's like, hey, you've got an employee that's not following policies. And then that boss talks to their employee and handles it however they deem. Each department operates independently in most corporations, but they all need to follow the same policies and protocols so as to not interfere with other departments. And this has made a massive, massive difference in cooling. Now we're talking a 30-degree drop, 25-degree drop anyway, 26. What is it, from 86? My math is bad today. 86 to 102 is 16 degrees Celsius. So a 16 degrees Celsius drop by simply making sure the fans are operating the way they're supposed to at default without any customization. That is much better, and this is why I test. I'm not testing for measuring my benchmarks, to set records. I'm testing to verify that things are operating the way that they should within a range, an acceptable range. I don't want to be in the far low end, and I don't want to be on the far high end. I want to be somewhere in between those two, and it will vary depending on what CPU and cooler we have. But we definitely want to run these tests so that if we give it to a customer, we can be confident that that customer is not going to call us with a complaint that something's overheating. Not that that would ordinarily happen anyway, because this is an extraordinary and completely unrealistic test. But you always get one customer. There's always one. And for all I know, what they're doing with it is running benchmarks on it, and that's what's causing the problem. So in this business, you just got to be prepared, and we're just trying to avoid avoidable support calls that end up upsetting the customer, upsetting the tech, and costing the company money. Even if the company is myself, I'm the company, and the customer's calling me and they're taking me away from money making to handle something that was already sold, that's an avoidable interruption to my day. And certainly the customer's probably not happy about having to call you, right? Nobody's happy. We've been into this test 7.5 minutes, and the highest temp we've seen is 86. I like 85 to be the max. 86 is only 1 degree away, so I'm okay with that. If that's the worst we get, totally fine with it. The fans are definitely very noticeable right now, and as our temps lower, depending on what phase the Cinebench program is in, you'll see these temps fluctuate, and then the fans will then react accordingly. There you go. Real life example in real time, live and unscripted. That's just the way techs work, right? In the real world, where you're responsible for other people's equipment, we remove any customizations except required by corporate policy, and individuals, generally speaking, are not allowed to make those changes. Home users can be a nightmare to service because they might be installing every little shareware or bloatware removal tool and uninstaller and cleaner and system tune-up, and the system is a mess. And then they want their little crutches because they don't like the menus now, so they got to go back to a previous version of Windows menu because, that's their preference, and then that causes a system compatibility issue after an update sometimes, or it stops working, or you get these weird artifacts because it's not from Microsoft, it wasn't certified by Microsoft. And if you're a tech accustomed to working on Windows 11, and now the Windows 11 menu is all screwed up and different, you can't work as efficiently, and you might have to figure out what the heck the software is this customer's put on. It's a nightmare. At least for most of us in IT, it's an added obstacle that doesn't need to be there, that likely creates problems that would have never happened. And if we could get users to just stop that, we'd probably go out of business. Except when working in corporate IT, job security is safe there for a long time. I should be able to tell when this test is done by simply hearing the fans. Instead of looking at the countdown timer, when the test is done and the temperatures go down on the CPU, the fan should quiet down, right? And then I'll know, hey, switch back over, we can run the second test. Oh, those fans just now quieted. So that means if I switch over now, that test should be done. Let's go back over to camera 2. Yep, it finished. And then that's our score. If you're curious, I don't give rats behind about the score. Then we'll do the single core test. And once again, we'll keep an eye on those temps, and we expect the fans to ramp back up as necessary. And then we'll see if we've exceeded any higher temp than what we've already recorded on the first test. But these results are far, far better. Looks like 86 is our previous high score. I want to call it high score. And, you know, even on the single core test here that's running, we're not really doing much on resources here yet. It's weird. Is it running? It's very strange. Like I said, it's usually the first 2 minutes of either test that really causes the fans to ramp up. And sometimes you can just tell by looking at the temps, because this is a single core test, which core it's running on. And one of these cores may just get really super hot here. But regardless, the fan should crank up. Like our maximum temperature right now still looks like from the previous test. Looking at current temps, core 8 is the one that's getting hotter than everybody else. So perhaps that's the one the test is running on. If so, I mean, usually I hear the fans crank up again, but it's pretty steady, pretty static. Interesting. We're nearly 2 minutes into the test, and I am not seeing much more than around 52 degrees Celsius. I don't know how it chooses which core it's going to run on. But regardless, we'll check back on this in 8 more minutes. And that means in 8 minutes, we're going to end today's show. We've gone on a little over 3 hours today. A little interruption and a power brownout there. But if you have any questions for me or anything you want to talk about, now is the time as we wait for the test to complete. After this video, I'm going to put the panels back on, replace any wire ties with nylon zip ties. The build is done. It is 100% completed. And then we've got more builds next week. We have 3 more builds coming up that I'm aware of. And we have a new Minis Forum PC to review soon, a couple weeks away. And we have one of the boards we're building is going to be on the new AMD Ryzen 5, not new-ish, but it'll be on, I guess what I meant to say, on the new B850 chipset. Those boards just got released from like Gigabyte, and we should be one of the first people to get one. And when we have it, it's the last piece we're missing to build a little micro ATX aquarium using a Ryzen 5 in a B850 chipset, which is much more affordable than the extreme chipsets of the 870E on the AMD side and the Z890 on the Intel side. So again, when the chips first come out, they always introduce them with the high-end chips first, with the high-end motherboards first. That usually, for Intel anyway, happens around Thanksgiving, you know, the fall, late fall. And then after CES and in that first quarter, whatever family of chips come out under that new line start to get released along with the more budget-friendly chipset. So instead of Z890, we have B860. And we already built on a B860, right? Didn't we? We did an Intel Ultra 5. What did I put it in? It's pretty bad. I built so many computers, I can't remember what I did with it. It's around here somewhere. So that's Intel's new budget line chipset. And of course, AMD's pretty much releasing theirs tit for tat. Joe Burnham said, "That's a beautiful PC, Carey." Well, right on. Thank you, Joe. Moonwolf Hunter said, did you hear back from ASRock and the case manufacturer? I did, and I explained that in yesterday's video. And yeah, you could go back and watch that at your convenience. David Martinez joins us and says hello. Andy is not clear which connector I disconnected from the board. So the board has numerous chassis fan headers. And they're all just like fan header 1, fan header 2, fan header 3. And then it has fan headers specifically for the CPU and for the all-in-one pump. So initially I plugged in these case fans to just a generic ordinary fan header, chassis fan header. And apparently ASRock's default settings on that is they are not adjusting based on CPU temperature. We'd have to go into the BIOS and change that default. Some motherboard manufacturers from other BIOSes default differently. It's not right or wrong, it's just different. We do know that the CPU fan will speed up and slow down based on the temperature of the CPU. And since all these front fans are responding to the CPU fan temperature, or they should be, then the appropriate place to plug it in would be the CPU fan header. That is where I should have plugged it in to begin with, in retrospect. However, we can go into the BIOS and we can tell those chassis fan headers how we want them to respond, because you could have temperature sensors around the case. And you could say, hey, if my graphics card area gets hot over here, then turn these fans up. And if my CPU gets hot over here, then turn these fans up. That's all customizable. But I'm trying to avoid the customization. I'm trying to keep everything to default so support is much easier. And if all it takes is simply moving a plug and then that problem goes away forever, I would rather do that than just adjust the BIOS and then forget I did that. Then the customer calls, or even myself might put this back up on a bench in some time and scratch my head going, I just updated the BIOS, and how long will it take me to realize those fans aren't cranking up? Unless I test it, and why would I test it? It may take a while before I realize the BIOS reset. When I plug it into the fan header for the CPU fan header, that never will ever happen. I'm avoiding a future problem. I'm thinking that far ahead. Keep it standard as much as possible, and you'll be unlikely to experience the same issue again that you've long since forgotten about. What did I do to fix this before? I can't remember. And how long will it take me to even realize those fans aren't, it took me a while to realize it this time. The whole test ran, and I'm scratching my head and went, wait a minute, those fans never got loud. So that's based on the default settings that the manufacturer has selected for their BIOS. And in theory, anytime you update the BIOS, you might go back to default settings. So you have to remember. And if you just have one computer, it's pretty easy to remember. But if you've got 70 computers, how can you remember when each one's different? This one's Gigabyte, and this one's ASRock, and this one's Asus, and this one's MSI. Good luck keeping, post-it notes. Just set them up right to begin with and leave it alone, and you never have to revisit it again. That's the way I see it. Ben Laird wants to know, how much did this cost? Fair question. The case retails for $399, which includes an 850-watt modular gold power supply pre-installed and a 360-millimeter cooler with RGB fans pre-installed. We were able to buy the case as a returned item on Amazon for about $260. It's a significant savings. And it had never been taken out of the box so far as I could tell. If we include that discount, which again, I had to look for it. It didn't get offered to me. You have to look on the page and identify it, know what you're looking at. Depending on if you want to go, what did we pay? Or how much would it cost if we bought it all new? If we bought it all new, there's a $140 price difference because of the savings on the case. So $400 on the case. I want to say about $320 on the CPU. So that's $520. The RAM we've got in here, I don't know, how much RAM did we put in here? 32, 64? I can't remember. And what NVMe did we? I can't remember that either. I'd have to go back. There should be a parts list underneath the video description, and you can click on the parts and see what they're currently selling for. Remember, this video may be up for the next 10 years, and these parts aren't even made anymore. So I'm going to guesstimate we probably spent about $300 on the board, about $300 on the CPU, and about $300 on the case. So those three components are $900. And then when you add the RAM and the NVMe drive and the license for Windows 11, you're probably at another, let's say $300 minimal. So I'm going to guesstimate around $1,200, which I think is very reasonable given how high performance this is and how high-end overall aesthetically, and the ease of the build is certainly more convenient. And then of course we have sales tax here, at least in Arizona. I don't think they do in like Oregon, and there's a few other places they don't collect sales tax. We got free shipping, which is good, because the shipping would have killed us for how much all this would have cost in weight to ship it. And if you wanted to put a graphics card in here, you could add another $600 to $2,000, depending on how high-end of a graphics card you want, which could take your $1,200 build to say $3,200, $3,600. In fact, if you bought a pre-built with a GPU in it, you'd probably be looking about that price, maybe a little bit more because the company needs to earn a profit. This is just cost, free labor. I think it's a solid value for the money. It's not the best computer money can buy. If you spend more, you can go to an Ultra 9. You can go to a higher end motherboard. Motherboards go up to $1,200 if you want to buy a really fancy high-end motherboard. We could go to 1,000 watt or 1,200 watt or even 1,500 watt power supply. We could go to a fancier case. I mean, it's very easy to go up from 1,200 from where we're at. So with that consideration, we could have bought a cheaper motherboard. We could have put an Ultra 5 instead of an Ultra 7. And we didn't have to go with RGB on the RAM for that matter. But there you have it. I'm going to guess about $1,200. How was our system doing? Let's take a look. It did finish, and our single CPU core there's our points. And you can see, although Cinebench R23 is kind of old now, our CPU is on top of everything else that they measured before it. You know, look at all an old Threadripper 2990 is way down the list compared to this modern Ultra 7. That gives you an idea of just how quickly the evolution of the technology is moving. So what was considered jaw-dropping performance a couple of years ago is now left in the dust by a cheaper, more accessible chip to the general public that doesn't require such high-end components that are as expensive, such as a Threadripper motherboard and chip and cooler. And it's just, it tickles me to see how attainable this technology has become to everybody. I'm going to go ahead and shut this down for now, and then we'll wrap it up and say thank you to everybody for hanging out with me today. And a super shout out to our friends. Whoops, where's my camera? There I am. A shout out to our friends that are members here and for your super chats, and of course those PayPal and gift card contributions, which I want to check one more time before we go. Should be here somewhere. Yes, Charlie Purdy, thank you again. swear there was another one in here. I don't see it. And if I look through our activity, it's over here somewhere. I see a 10-pound contribution. I'm going to work my way from most recent to the earliest at the beginning of the show. We're going to work backwards. 10 pounds from Mark Gaines. Thank you to Mark, of course. Peter VZ, thank you for your super chat. Martin Hogg. Oh, maybe that's what Martin was talking about. Martin contributed £4.99. Thank you, Martin. I just saw that now. Planet Cryos, thank you as always. Harry Thor with a $10 Canadian contribution, and Nick Caffrey with €5. Thank you both. Andy Kane, Dwayne Blackwelder, and Charlie Purdy all renewed their memberships today. Thank you, guys. William Denton contributed in our super chat, as did Ben Laird. And of course, our good friend, Buster, Peter Laycock, joining us from Scotland. You guys are amazing. And to everybody joining us in the chat, thank you for hanging out with us and being a part of this amazing community that wouldn't be the same without you. Each and every one of you. Thank you, of course, to Mara for all the hard work she does in the background with all the administrative tasks. And our friends, of course, at SCD Keys. They can get you a really good price on legitimate legal Office, Microsoft Office product keys, and Windows 10 and 11 product keys. Why pay more and get peace of mind that the product guaranteed to activate 6 months of free support? All those details and coupons are available in the show notes, and along with the parts list for today's build, also in our notes below the video. Wow. Either that was thunder or the wind just knocked something big over. I think somebody's telling me to wrap it up. Thank you so much for watching. We'll see you all again very, very soon. And until next time, bye for now.